Madam, 1 minute, madam. Madam, okay, start, madam.
Most respected Director of IQAC, Professor Adiyode Nambi sir, respected resource person, Professor K. Thiagu from Central University of Kerala, participants, good evening to all. I would like to start the session with a thought. Progress is possible only if you think differently. And also, I would like to introduce today's resource person, Professor K. Thiagu. Professor K. Thiagu is working as Assistant Professor of Education in Central University of Kerala. He has 2 PGs, MSc Mathematics and MSc Psychology, 2 MPhils, MPhil in Mathematics and MPhil in Education, and PhD in Education. His areas of specialization are psychology, research methodology, and educational statistics. He has published 75 articles in national and international journals. He has published 3 books related to technology, that is ICT in education, technology and teaching learning skills, assistive technology and inclusive education. He has attended and presented papers in 45 international conferences and 80 national conferences. He has served in many capacities like chairperson, coordinator, examiner, member in various conferences and in institutions. He has delivered 20 guest lectures. He is a recipient of many awards, to name a few: Sudesh Kumar Memorial Best Researcher Award and the Best Paper Presenter Award 5 times in various institutions where he has presented the papers. Such a renowned educator to handle the session on research design. On behalf of IQAC, welcome you, sir.
Thank you so much, ma'am. Hope my voice is audible. So first of all, I share this entire thanks to the entire Annamalai University faculty member. Special thanks to the Sailila ma'am to provide and for me to share my views related to research designs. So I hope my screen is to be viewable to all of you. So I request all to interact with me during my presentations, because for sitting in the evening class is not at all fair. Okay, that's why I request all the participants, if you have any doubts or if you like to add some points, it will be helpful for me to be learned from your end, because the research we have to learn mutually. Because the research like this only. So we could not, no one can have know the 100% of the research things. We can learn mutually the things of the research. So kindly share your valuable inputs or the suggestions. It will be helpful for my presentation too. Yes, I'm going to focusing on the research design, and the madam is already pointed out that I don't be cover the experimental design as well the exposed factor, because there is one more section related to that. Therefore, today I'm going to focusing on the main area of the what is called research design, why it's need for an hour, why it's need in the case of research, and I can divide my presentation into 2 segments. One is called quantitative based research design, other one is called qualitative. In the quantitative only experimental design, research design comes, that I will skip it, but I have the PPT slides. If need, I will share that material also. But I'm going to focusing on the 2 things: quantitative research design. There I'm focusing on the this one, survey designs, survey method design. And in the case of qualitative design, I'm focusing in what way we have to design the qualitative design if you're adopting the sense. The third one is a mixed method research. So these are the 3 things I'm going to focus in. And parallel, I'm going to highlight some of the elements which is related to the research design also. So just I like to start my presentation with a small slide as well as the some kind of quote also. It is said by the Warren Buffett: "An idiot with a plan can beat a genius without a plan." Actually, it is so related to, it's very much correlated to my topic also, because the research design is look like this one. If you're not doing a research plan or research strategy, if you're not making any kind of blueprint, or you're not prepared any kind of structure before attempting any research, we could not finish our research task. So before, when you're thinking about research, kindly make some kind of blueprint. What you're going to do, which are your variable, in what sampling strategy you are going to adopt, in what way you're going to do the data analysis, finally how the interpretation you are going to write. So like this, you have to meet some kind of structural blueprint. That's why in Tamil, some of the films also, everything we have to plan it well. So plan saying. Like this, there is a proverb also there. So whenever you like to do anything, any attempt, we have to plan well, because the planning is a main important strategy in the case of research to finish our research work or research things in a perfect manner. If you're not planning well, nothing is to be possible in the case of research. That is why I quote here, because some of the genius, because in the case of higher education, a lot of genius we have. But what the problem, they have a lot of ideas. But why the people not able to finish the PhD? Because they could not know what is the exact strategy, what they're going to do in the case of research. They have a lot of idea, but they could not make it as some kind of framework. Due to the reasons, most of the PhD scholar, they could not find the way to finish that PhD. That is a bigger challenges I see in some of the PhD scholars. They have very much intellectual. They're very good in all the aspects. But the problem, they could not design. They could not know what they are going to do. That is a bigger challenge for them. Therefore, I request all, before thinking, whenever you're thinking about the research or the project, kindly make some kind of framework. What you're going to do, in what way you're going to collect the data, in what the procedure you are going to do, in what way you're going to write the interpretation. Everything should be make some kind of structural plan here to make it. Yes. So why this research plan is needed for an hour? For this, just I'm showing you 3 or 4 slides, which is related to the previous means one. If the people's not planned well, the progress is going like this one. The first year, second year, third year, and final year, it may goes, it's like the infinitive. They could not be finished the PhD within a stipulated time because they don't have a proper plan, particularly the research design, they are not make it in a perfect manner. They made the confusion with what they're going to do. That is the biggest challenges in the case of research. Therefore, when you started the research work, kindly make some structured plan. And the next problem for the PhD scholar, they know how to join the PhD. They know how to join the PhD. In what way they have to write the proposal, everything they know. But they could not know the way to do for the experimentations or go for the data collection. Even some people, they did the data collection. After that, they could not know in what way they can do the standardization procedure or how we can go for the data analysis. Lot of issues they faced before finishing the PhD because they don't have a proper plan. There's no having any kind of pre-notion what they're going to do. So that is the issue for them. And the next thing, some cases we are planning is a narrow road because the research is not a straight road. We cannot reach the research in a straight. Normally, in the case of research, we may tell us a scientific procedure. We can go with a sequential. Exactly, that's correct. But when you're thinking about the plan, we feel that the plan may be a very easy way to reach that particular destination. Or we can finish the things very simple, but it's not at all correct. The reality aspects, we may face a lot of difficulty. Even see, my scholars, the last 1 year or 1.5 years, they could not go for the data collection because of the COVID. The sudden changes happened, a sudden pandemic happened due to the reasons they could not move for the data collections process. This is a bigger challenge for all the PhD scholars. Even some of the scholars might having this kind of issues because we plan in such a way that we can go directly to the particular institution or the particular sample group. We can collect the data, but now the pandemic is not allowing to go directly. Then what we have to think? We have to change our strategy, or we have to change little bit modification our plan. So these are things we have to think before attempting it. Now, particularly the problem with experimentation for people, those who like to do experimentation, it is not at all possible because of the COVID. Even now, my scholars, I told them to go with experimentation also. You can go with online. For example, control group, the normal online lecture, the experimental group, the strategy which you are going to use, so that you can go with. So like this, we can change some way the strategies or the plan which you already predefined it. And just I like to move directly to the meaning of research design. So here I given you 3 important key terms, which is more relevant to the topic research design. Sometimes you might having the confusion. What is research design? You have the confusion might have it. So for this, these are the 3 important key terms. One is called blueprint. So I hope you know before going to the any kind of construction work, they have some blueprint. They have 2-dimensional images. that how the building should be, the interior and exterior things. Based on this one, they started the research work. So they started the construction work. Similar in the research, we should having this some kind of blueprint, what you are going to do, in what way you are going to. So the main important elements in the case of research design, one is called method, which you are going to adopt. The second one, the sampling strategy, which you are going to adopt. Suppose you are going to take a randomization or non-randomization, that you have to think much. The next thing, the instrument which you are going to use. The instruments mean the tools which you are going to use. Suppose you are going to go for the awareness, you can better to measure the awareness through the questionnaire. If you like to go with the attitude, you can better to use as a scale pattern. So based on the variable, we have to select the proper instruments. So these are the main important things we have to plan well in advance. So that blueprint we can make it. Then second term, it's other names of blueprint, we can call as a strategic plan. So it's like a planning one. Then third one is a framework. So the three terms, it's closely related to the term of research design. Some people having the wrong understood the research design means some kind of flow chart, exactly flow chart. But the flow chart, it's having some kind of meaningful linkage. What is the first step? What is the second step? What is the third step? What is the fourth steps? That steps, it leads to finish your research work. So that kind of structure you have to make it. So the three important terms which I highlighted, it's to be very close to the research design term: blueprint, plan, or structural framework. Structural, that word is important. Structural framework. What is called structural? Structural framework one, there is a framework. It's having some kind of structural. It's having some kind of structural. Yeah. So that kind of thing is called structure. Means some kind of proper order sequence should be there. We could not be violate that kind of things. Yes. So the same, the key terms which I'm using for explaining the definition of research design. The research design is a kind of it's a kind of blueprint that I already mentioned, that look like the building plan that we prepare before actually carrying out the research. Even I found some of the research scholars, when they finish the PhD, when they submit the PhD, only they're making the blueprint, or they're making the research design. That is a problem for them. Before going to the research itself, when you finish your what is this title, then you have to think the process or the progress of your research. In what way you are going to finish your research. For this, you have to make such a wonderful plan. That is called as a blueprint. It will be carried out before attempting the research. And research design is a strategic plan of the project. So here the project represents research only. That set up broad structure of the research. So it's talking about the structure of the research. Research design is a framework of research method, that technique chosen by the researcher. So here the term is important. So because each methods having the different kinds of strategy we have to follow. Suppose we are going to experimental method, there is an experimental method. We have the three types of things. The one is called single group design, quasi-experimental design, true experimental design. So we have to think which strategy is more adapt for this, which the method we have to adopt for particular the topic. So because the variable is very much close to the method which you are going to adopt, so we have to check what is the variable you are going to use. We have to find. That's also the main thing. And the techniques which you are going to. The techniques means what we are going to collect the data. Whether you are going to use the questionnaire or achievement test or any scale or any different funds of scales we have. So which things you are going to use. Even the techniques, in the case of qualitative, we can think about the interviewing schedule or the focus group discussions, a lot of the case study, a lot of techniques we can use for the collecting the data for the qualitative research. These are the things we have to plan well in advance. So the research plan can make it or can plan before attempting the research, not for the end of the research. The research design is simply structural framework of various research as well as the techniques that are utilized by the researcher. All right. So even some cases, if I suppose I'm like to measure my some of these come for the evaluation. So when I like to evaluate any dissertation work, first I'd like to go with the third chapter. In the third chapter, whether they're given some kind of diagram representations or some kind of flow chart or some kind of table representation, which they highlighted as a research design, because we don't have a time. Normally they examine it, they don't have time to read the 200 page or 300 page. So in what way they are going to read the entire presentation work or the thesis work made by prepared by the scholar, in the sense only they can see some of the diagram representation, or they can see some of the main important aspects in the third chapter, fourth chapter, and fifth chapter. Therefore, the research design, it should be mentioned very clear. So it may be helping to the examiner to just to look onto the particular flow chart or the particular table, then immediately they can find, oh, this is the way you attend the research. They may get some kind of general conclusion about what's the research strategy you're adopting. Just like to show some of my scholars' work, and then you can understand how we can frame this kind of things. I can move to the one of my, so one of the scholar, she's awarded the thesis. It's a third chapter, just I'm showing. But for her, it's an experimental method. So just I'm going to show the way she's made this. She's used the API format only. So she's using a flow chart. This for the variable of the study. So what is the variable she's using the independent variable, dependent variable, demographic variable. So these are the part of the research design. So she's explained the variable in a separate flow chart, but it is not exact research. Research design means the entire things you can explain in a well-structured manner. For her case, she's adopting the experimental design. But in the experimental design, which the experimental design she was using, she used the true experimental design. So this is a flow chart. It is talking about the particular experimental design. So some people are having the doubt, what is the difference between quasi, what is the difference between the true experimental design? So the main difference between the quasi experimental design and true experimental design, it is based on the randomization, right? So for her is a true experimental design. Therefore, when you made a flow chart, see the first term, the random sample is drawn. So why she's focusing random sample? Because that immediately she can get some kind of clarity. The true means we need to take a random sampling. If it is quasi, no need for the random. So therefore, there is a title, the true experiment design, it directly proportionate or relate to the flow chart. She started with the first step random sample, and she is given divide the two groups. Treatment group is called experimental group, then control group, then there is a error mark pre-test for the both group. After she is going for the invented cluster model for one group, the existing model teaching for the control group, then finally she is checking the post-test. It's a small images, right? It's a small images, but it gives a clear picture about how she attempted the research work, carried out the research. Particularly the experimental design, what the experimental design she adopted, and how she finished, how she structurally finished her work. That we can see from here. And the second thing, she's given us here the general phases of the entire research in a tabular form. It is up to you only. If you are giving us here diagram representation or a tabular form, it is up to the scholars only. So just I'm showing how it fixed. So suppose if you have the survey method, you have to plan in what way you have to be show the survey method designs and all that. I just I'm going to my PPT slides in later. But see what she did for the experimentation procedure. She's given the stages. Just I'm not talking about what is experimental method here. Just I'm focusing the research design, how we had to be make it. So what she did, she divide the entire research of her into 7 phases or 7 steps. In the step 1, the phase 1, selecting the sample, that through the randomization she adopted. And phase 2, in the phase 2, she is having the 2 stages. One is called identifying the invented cluster model, that is nothing but her independent variable. Then second stage in the phase 2, the tool constraint. She is having the 4 tools. She considered all the 4 tools here in this phase 2. Then phase 3, she is moving to the pre-assessment, right? Then phase 4, she is going for the treatment. Then phase 5, post-assessment. Phase 6, data analysis. Then phase 7 is the findings and interpretation. And finally, there is report submission. And see, the tool construction and validation, it comes to it all together. What is it? Combine all the reliability, validity, item analysis, file history, everything is to become in a single stages report. So this way, we have to clearly mention the way you are going to do the research work. For example, she is adopting the inverted cluster model. There's one more diagram also she is given. This for the how she prepared a independent variable. So she is preparing some kind of flipped cluster model in how many phases he adopted for developing this model. For each phase, for example, in the case of independent variable construction, what is the phase is adopted? Dependent variable also, what are the steps he used for preparing the tool? Like this, you see, she made a diagram representation for each of the tools. That it gives a clear picture about how she did the research work, how she carried out the research work. So the phase one of this was the independent variable. See, find the identification phase means the content selections, the model selection. Then she's developed the content, then transaction and evaluation phase. This is for the independent variable. So she's using some kind of, what are the strategies she adopted? She's using some kind of diagram representations. And this are the, this is also another model. So she's showing the model. She's using some nearly 3 or 4 models. But even though she's given some kind of diagram representations about the model strategy which she adopted for her independent variable. Because she flipped classroom, in the flipped classroom, she's used nearly 3 models. And this for the independent variable. In the case of dependent variable, see the dependent variables is giving a different how she prepared. That's also plan. So for each one, actually the research plan means the gender one. So the first I shown one table, no, that's called research plan. But when you're going to think about a plan, you have to plan for each one, for constructing the tool or constructing the what way you're going to collect the data. So for everything you can plan it well. And all the things combined together, you can make it a single flow chart. In what way you're going to attempt your research work, that you have to make it. So this, yeah, this is another one. How she prepared here, the pre-test and post-achievement test. For this also given a different phases, entry phases, phase 2, then stage 1, stage 3, then 10-minute behavior. For each tool, she is given a separate pattern, how she attempted for the tools construction. So everything she clearly mentioned these things. So the same way, the research design, we have to give you a proper blueprint or some kind of framework, which we highlighted in the, particularly in the 3rd chapter, because each university, they're going with the different format of the order. Yeah. Just I'll move the next one. Yeah. What is the need for this kind of research design? The main purpose of the research design, this is said by the Block and Chain in 1976. What they highlighted, yeah, research design provides a blueprint of operationalizing the research activity. So which are things you are going to do? It gives you some kind of idea. So the broad idea, what you are going to do the next. It defines the limit and scope of the research work. For example, when my scholar, the 2 years before, she planned that she's going for the, what is that? Random sampling techniques to collect the sample of the postgraduate students. But unfortunately, there is a problems now because of the COVID. So this is a main limitation for this. Therefore, what she did, instead of going the random sampling, she's going for the different sampling strategy, because she's going to collect the data through the online mode, through the some kind of tools like a Google Forms or a Survey Monkey. So through online, she's going to collect. Therefore, we have to think about the different sampling techniques for finishing the things. So these are things we can easy to fix before that. It provides an opportunity to the researcher to foresee. So what are things you are going to do? It's like a bird view. It gives you some kind of foresee view, possible areas problem in the process, and carrying out the research. So once you fix any kind of research design, you can understand where you have having the problems. When the problems arise, how we can resolve. These are things we can plan it well in advance. So these are main functions or the purpose of the research designs. Yes, this is a flow chart. This was the entire research process flow chart. The first one, define a research problem. This is entire, this is normally is nothing but the research progress or research process, the A to Z. So how we can start the work, how we are going to finish the work. So the entire thing is come together, it's called research process. So define a problem, the step number 1. The review of literature, second step. Formatting the objectives, IQAC, the third step. Then designing the research, including the sampling design, correction of the, what is that, preparing the tool, and sanitation procedure. These all things may come with this. Then collect the data, then go to the analyze the data, then finally interpret the report. So this is steps of scientific method. Yes, the same things, the other because the different authors given the different way. So there's one more author, one more textbook I found this. There is a 10 step they suggesting. One is called defining a research problem, review of literature, identifying the universe. This is nothing but the population. We have to find the populations as the sampling in the third stage. Then after that, you can go with formulating the hypothesis and identifying the variable. This is another steps. Then after this, we can go with the selection of research techniques and methods. So we have to adopt the proper research design, so research techniques and the methods. Then we can go with the standardization of research. This is different from the standardization tool. We have to check the standardization of the research. Then pilot study. After preparing it, we can go with pilot study. Then collect the data. Then we can go to the analyzing data. Finally, interpret and report writing. So this is the way the research design, the progress. That the 10 steps of the research design, it might be that even it will be apt for all the cases. So this particular research design, it apt in the case of quantity method or qualitative research design, or in the experimental, mixed method, because we can divide the entire research approach in the three way and based on the data. One is called quantitative, qualitative, other one is a mixture. In the quantitative only, we are using the survey method and experimental method and all. For the qualitative, we are thinking about the philosophical research, or in the case study, or in the what is it, socio. So some of the ethnographic research. These are things under the qualitative. So, but the progress that the design, it will be common, but some way it will be differ. For example, the way of collecting the data, it should be differ from the quantitative to qualitative. It will be differ. So we cannot go with the same quantitative procedure, quantitative research procedure for the qualitative research analysis. So we already know that the types of research. The types of research, we have different way we can do it. For example, if someone asking me the types of triangle, immediately we may tell the responses. In the case of types of triangle, we can divide the types of triangle based on the two way. One is called based on the angle, based on the sides. If you're talking about based on the angle, we can tell as an obtuse angle, acute angle, as well as the right angle triangle. When the case of the sides, we can talking about Euclidean triangle. So like this, we can give a different types. So the similar way, the type of research we can divide into the different aspects or different criteria which we can divide it. If you look onto the objective, this is we can divide, because generally the people having the confusion. What is the difference between the survey method and quantitative research? They have the wrong understood. They feel that both is different. Quantitative and survey experimental, all things to be different to each other. So it is based on the criteria which you fix. Based on this, when we have to divide the types of the research. In the case of objectives, based on the objectives of the research work, there is a three way we can go with the types of research. One is called fundamental research, applied research, action research. So in the case of applied research, there's nothing but the experimental research might comes here in this case here. Based on the data, so based on the data which you are using, we can divide the research into two way. But one more thing is called mixed method. That's what I'm focusing. One is called qualitative research based on the data. Qualitative means there is no statistical procedure. Only the qualitative representation. Only the attribute based we can interpret, or we can write a findings and all. Other one is called the numerical based research. That is called quantitative. If you're adding the two things, so in one phases we are using the qualitative, in other phases we are using the quantitative, then it's called as a mixed. So based on the nature of the data, we have the three. One is called qualitative, quantitative, then third one is a mixed. In the case of findings, so normally in the finding wise, we are making the findings into three way. One is called the explanatory, the exploratory, and descriptive. Even for the factor analysis also, we have the two types of factor analysis. One is called confirmative factor analysis, other one is called exploratory. So that I hope you understood. The explanatory means what is existing, that it will be explained. Normally, it's purely based on the quantitative. The exploratory means we cannot know the basic things, so we know the basic theory. From the basic theory, we can explore a different aspect and different components. We can come to we can create some kind of new theory and all. So we can explore in a very big manner. So normally the exploratory research may come under the qualitative. Then the third one is called descriptive. It is purely based on the survey method. So this way, the findings based becomes. Then in the case of experimental manipulation, so it's nothing but the experimentation process. We can, our lab, normally we can call it a laboratory method. In the case of experimental laboratory, we can divide the entire research into two types. One is called experimental and non-experimental. So experimental means we have the independent variable, dependent variable, and the independent variable, we have the control over it. So we can manipulate the independent variable. So some kind of settings, controlling settings, we can go with the experimental. What is called non-experimental? Even when I hear the term and during my PG, I confuse that what is called non-experimental. Actually, non-experimental is nothing but the survey method. The method other than the experimental method is called as non-experimental. But normally in our mind, we think that only the survey method and the experimental method. But we can call the opposite terms which you use for the experimental method is called non-experimental method. It seems that the method which is not under commanded the experimental method, it's called as a non-experimental. That's only the difference. Therefore, the survey method, what is that, case study, these are things may come under the non-experimental. Based on the approaches, based on the sample observation. Suppose I'm observing the sample in life more than 10 years, 15 years. So such a long period I'm observing, I'm writing the interpretation, means that's called as a longitude. But at the same period, I'm comparing 2 or 3 different groups, then it's called as a cross section. It's based on the approach, the sampling approaches. So therefore, the types means we have the different types based on some specific criteria. But here I'm going to focusing on the 3 approaches and the designs only. The first design, I'm going to focus on qualitative research design or quantity. So quantity or quality I'm going to discuss. What is called quantitative research design, what is called qualitative research design, and what is called mixed. These are the 3 things I'm going to focus much. And which for preparing any research design, we have some kind of set of a checklist. We have some kind of checklist that we have to crack check. Your research design satisfying all the checklists. If satisfying, your research designs are very powerful. So you are doing a proper track. Like this, we can come for the conclusion. Yes. So what is called qualitative research? That's why I'm using the term as a good. So we can measure the things through the word representation, not for the magnitude representations. We can measure anything, or we can write anything, or we can analyze the things through the qualitative measure, not any quantity. No need to take any kind of mathematical things, or don't be quantified. If you are quantified anything in the finding, then it's called as a quantity, right? So the quality means you have to exploring and understanding the meaning of individual groups. Or is it ascribed as the social and human problems, but in a qualitative manner without any numerical representations. So I'm using the term good, excellent, like that is a good. What is called quantitative? It is purely based on the numerical or magnitude value. We can examine the relation between the 2 or 3 variables in a magnitude way. And the third one is called mixed method. It's a combination of the 2 methods. If you're adding the 2 methods, qualitative and quantitative, then we can get the mixed method also. That's why I use the term good plus. Some cases we can go with the qualitative, some cases we can go with the quantitative. Or we can embedding, because even the mixed method, different methods are the embed method, then exploratory method, explanatory method. Lot of approaches is available in the mixed method also. We can go one by one very clearly. The first one is a quantitative research design. So in the case of quantity, as I already mentioned, that we need a numeric. So that's why I show some kind of percentage here. And normally we can show the report through the diagrams only, or some kind of numerical way we can show. Therefore, the quantitative research design having the numbers, graphs, figures, pie chart, and all. This is possible. We can do the data collection, and finally we can convert the data collection to some kind of numerical representation. But what is called qualitative? In the qualitative, we don't have any kind of magnitude value. So here we are going to find the answer of what is it, how it is working. This way we are going to measure it. We are going to explore the cause. What is the issue, exact issues, what becomes in the future. So we are going to find the things through the exploratory method, exploratory way. So here the given some kind of example case studies are the mainly used for the qualitative research design, or we can go with some kind of ethnographic research is also part of the case qualitative research designs. So only the main difference between the qualitative quantitative numerical data only. So here the entire two important research design I can divide into I can divide the difference into 6 headings. I'm giving you some example also. Generally, the quantitative research, it is called fixed design. So sometimes the net examination they ask the questions. What is a fixed design? So we don't have much flexibility when you go for quantitative research. Suppose I like to do a t-test means I need a 2 variable, independent variable, dependent variable. Dependent variable should be a continuous. Independent variable, only 2 classifications like male and female, but it will be categorical in nature. So this kind of thumb rules we have to satisfy. Otherwise, you cannot go with any kind of quantitative research. Even for doing the data collection, everything we can go with here some kind of fixed norms. Suppose I'm having the tool of the awareness in a 2-point scale. So I could not go with the calculation for the 5-point scale calculation for my research work. So because there is here some kind of thumb rule we can adopt while doing the quantitative research, therefore it is called a fixed design. We don't have much freedom to make it as we like. That is not possible in the case of quantitative research. But the qualitative research, it's also called as a flexible design. Suppose I like to collect the data from the mental retard, but today I'm not possible. Tomorrow I'm going to collect from the principal or in the students, or the special students directly, or the parents. So I can flexibly manage, and even I can ask the different questions to the different people. But in the case of quantitative, suppose we are using one tool for checking the ICT awareness. The same tool only you have to give for the 1,000 people, right? But in the qualitative, it's not like this. Based on circumstance, based on the sample, we have to change the questions during the interview time. So therefore, a lot of flexibility, it will be possible in the case of the quantitative research design, but the quantity is not that much. And see the things, there is a main difference. The quantities, we can putting the ideas and hypothesis to be tested. And it concentrates the general ideas. Normally, this is for developing a hypothesis. It for the testing hypothesis. There's 2 differences. Normally, the quantitative research, we are using the null hypothesis to test the null hypothesis. Normally, the testing is possible through the null hypothesis only. Here, the testing the hypothesis is possible. Here, developing a hypothesis or developing a theory, it's possible in the case of qualitative research. And here, we are using the mathematical statistical analysis. Here, we don't have any kind of data analysis, but there is a data analysis, different data analysis, not in a quantitative basis, like a qualitative data analysis. Here, we are going the pattern like summarizing, classification, analyzing of data through the word format, only through word. For example, we can check the number of words frequently used by the people. So some people, they're using regularly some specific words or specific thing they may focus on. That we can check the frequency analysis, but in the word representation, not for the number representation. Then in the case of expression, we can express the quantity things through the numbers, graphs, tables are the most common forms of expressions. But here in the case of qualitative, the expression through the words only is much. And the next thing, the sample. So in the case of sample, the participants to be large in the case of quantitative, but qualitative, it is flexible. We can fix it, and few people also more than enough to go for the qualitative research. And in the case of questions, when you observe deeply, most nearly 90 to 95% of questions in the quantitative research, it is a closed representation or closed questions only. So even the multiple choice or in a scale format, it will be closed. They could not give us their own answer from them. We can give you some specific response. They have to select the response from the end. Therefore, it's a closed response only possible in the case of quantitative research. But when you're going to prepare a tool in the case of qualitative, the questions may be open-ended because you are going to interviewing the people directly. No, you can ask any kind of interviewing schedule-based question. It will be open-ended question. It's best example in the case of TV shows. The people are interviewing the experts. No, they're asking different questions, right? If you have any doubts, because some people are raising their hands, kindly type in the chat box, please. Or you can, if possible, I don't know whether the host has the freedom to talk to me. If possible, you can talk to me. Otherwise, you can ask your doubts in the chat box. It will be helpful for others also. The next thing is the key terms. Generally, there's some of the key terms which is more relevant to the quantitative research. One is called testing, measurement, objectivity. Because in the case of quantitative, the data which you are going to collect is objective in nature, because each question having only one response only, whether it's correct or wrong or a moderate, but it's only one responses. Then replicability might be the next thing. But in the case of qualitative, understanding, context based, complexity based, and the subjectivity, because the open-ended question generally it may be comes to the subjectivity only. Then the next is an example. So the example of the quantitative, descriptive survey, the experimental, or the case study is for the example of qualitative research. Right. Now, so straight now we are discussing about the two research designs differences only, the basic differences. Now I'd like to move to the third one. So I'm adding the third one in between. Why I'm adding in between the sense, then only we can understand the exact mixing, the mixer of the quantity and qualitative. So the left side is a quantitative method, the right side is a qualitative method. So here everything is predetermined. It is an emerging method. So here mixed methods, both it come predetermined based as well the emerging things. In the case of mixed method, sorry, quantitative closed question, open-ended question, it may apt for the both. So mixed method means we can take both the things. You can take the quantitative methods as well the qualitative method strategies. Then you can merge the two. In the case of quantitative, we have the attitude data, census data, observation data. Even the observation data, we can convert it to a numerical form. But here also observation data, but not in a magnetic form. They can convert it as a quality, like a word representation only. Performance data. So, for example, the achievement test or the LSRW scale, this was come under the performance data for us. So here, qualitative interview data, document data, audio visual. And in the case of mixed result, we can go with the methodology. For example, some phases we can use the quantitative, some phases we may use the qualitative. Based on the phases, we can adopt the particular data, the tools, and we can collect the data properly. And statistical analysis for the quantitative. This was the test and image analysis for the qualitative. Here we can use both analysis, statistical analysis, parallel text analysis. Then we can write the interpretation based on the statistical interpretation. Here we can go with the pattern interpretation or theme or the word interpretation, like the frequency of words they're using. But the together combined is called the database interpretations, because some cases your statistical as well as the qualitative data, it may be matching. That's called triangulation. We can cross check, even we can measure the same thing through the quantitative manner as well the qualitative manner. For example, I like to check the students' performance of something, so student performance. For example, life skill performance. So how they getting the life skills. I can give you some questionnaire. From this, I can get the data in a quantity. But one more strategy, just I'm going to give some tasks to them. From this, I'm observing in what way they are learning the life skill. So just I'm observing, I note the points. So here I'm going to do the triangulation of data triangulations. So one way I'm finding the life skills through the quantity. Other way I'm going to measure the person's life skills through a qualitative manner. So this is the things we have to find. And see the next thing, the quantity, quality, and the mixture. Here I'm giving some of the names of the things. The quantitative, we have the experimental design. And the next one is called non-experimental design. It's nothing but survey method, or the method which is not involved in the experimental design is called non-experimental design. The longitude designs. These three things come under the quantitative. In the case of qualitative, different qualitative research are there, even the textbook analysis, then case studies, narrative research, phenomenology, ground theory, ethnography. So these are theories may come under the qualitative. Mixed method, these are the research designs are there. Convergent design. Convergent means like both, for example, mixed quality this side, quantity this side, then merge point we can check the interpretation. The explanatory means You can start with quantitative and end with the qualitative. That is called explanatory sequential. Exploratory means explore means automatically qualitative. So we have to more emphasize the qualitative. You can start with the qualitative and you can check the next phase is here quantity, small quantity aspects. Some of the methods it will be blended with each other, like the same. We don't have the different phases of quantity and qualitative. We can use the both quantity to qualitative at the same phase. That is called as a embed method. That is, therefore, there is a 4-way we can divide the mixed methods. And this is here some of the basic idea about the research design. So when you're thinking about research design, the 3 important aspects to be merging are interconnections, but each one to be related to the each of us. So that's why I use this diagram. On the research approaches, normally we have the different approach of qualitative, quantitative, and mixed method. So here, how we can make it as a research design in this based on the philosophical worldviews. What is the philosophical worldviews? So our research we are doing for the worldviews, and because we are doing the research because of the society. In the case of worldviews, we have the post-positivity. It's purely based on the survey based, like survey things. Then constructive is for the qualitative based, transformative and pragmatic is for the mixed method. So this way the worldviews may comes. Pragmatic means practical based. So these are the classical worldviews are there. And this classical views, it may be merging or interconnected with the designs. So designs which are using quantitative designs, qualitative design, mixed design. And the designs may mixed with research methods to collect the data. So which are the methods we are using for data collections? The questions we are using different, data collection procedure may involve, data analysis may involve, then interpretations to be involved. So all the things may come under the methods and techniques which are adopted. Therefore, the 3 factors are the 3 important elements which may interrelated to each other, each of us. For example, I'm taking a survey method. Automatically, the survey method is satisfying the positivity, and it satisfying the quantitative, and it's satisfying the for example questionnaire or a survey I'm going to take. Sorry, questionnaire I'm going to take. I'm using some kind of data collection procedure, sampling strategies. I'm doing some parametric and non-parametric. Then finally, I'm writing the interpretation because based on each of the factors only, we have to fix the different aspects of the research. The same research design having the 5 phases. I hope I'm audible. There is a comments from Amit Kumar Shah.
Yes, sir.
Yeah, thank you. Amit Kumar Shah, kindly check your net connection. So the research design having the 5 steps. The same thing which we are discussing in a different way, qualitative, quantitative as well mixed. But some other things may come under this only. And when you're thinking about the research design, there are the 4 basic characteristics. This much you should be aware of it. Your research design having 4 characteristics. The first characteristic is neutrality. That is why we are thinking about the random sampling or bias, because the research is not a biased one. We can do, that is why we are taking the sample is high population. If you are taking the sample very less, automatically there may be bias. Or if you're taking the sample only for the convenience, only near to you, that also may be a bias. Or you can write your interpretation based on the things which you like. You see the YouTube, lot of people, they're interpreting the things based on their thoughts, based on the caste, based on the religions. So they given a lot of unwanted comments in the YouTube because there is no neutrality. We cannot find in the case of social media, which is correct, which is wrong. Because it is not a social media is not a authentic sources, as well as it's not like a scientific things which cannot find regularly there, right? But in the case of research, it should be very neutrality. The researcher should be very neutral. You cannot be biased. For example, I am belongs to one community. I'm doing the research for one community. Then immediately I won't be emphasize that my community is so high like this. We could not be put like this. So you should be check the exact fact of this particular things, and we have to highlight that one only. So we could not be biased at any cost in the research design. So that is why we are taking the neutrality. We are ensure the neutrality through the sampling techniques and through the data collection process, through the data analysis, and how we are writing the interpretation. This is a way we have to check, we can showcase our neutrality. The main characteristics of research design is neutrality. In no way your research design should be biased, or the things which are going to do, it won't be biased at any cost. The second one is reliable. For example, there is a lot of studies, it's already there. That studies more than 20 or 25 articles, but the results look like the same. But when you attempt the research, it will becomes a different output compared to the other 20 members, some kind of issues or the new data creations, because that is called generalizability. If the 20 articles or 100 articles, it's showing the same findings, how only your end it should be different, because you are not taking the proper sample procedure, or you are not taking through random issue you are not taking. That is the issues may come. Therefore, it should be checked the reliability of it clearly. And the next thing is the validity. So whenever you are going to measure whether the particular tool should be measuring the exactly what you are going to measure, that is the main things we look onto to measure anything through any kind of questionnaire or a scale or the interview schedule which are going to adopt. Kindly ensure that one. Then your report or the research design finally gives the generalization report. It's not for the sampling. That is why we are talking about inference statistics. Normally, the inference statistics, even we are doing the research for the sample, but the interpretation, the final outcomes, final result, we can give us a populations based on. That is why it's called inferential. So we can find the inference, or we are giving the interpretation for this population group, not for the sample representation. So this is the way we have to check the characteristics of research design. Now I'm moving to gradually to one by one. One is called quantity research design, the first one. So just I'm going to brief which are the checklist. It is essential while attempting quantitative research design. So in the case of quantity, the first one is a survey method. Because I'm focusing the quantity only two methods. One is called survey, other one is called experimenter method. But the experimenter method, there is one more lecture for you. Therefore, I'm not focusing much. Only the survey method I'm focusing much now. In the survey method, that is definition and all you know. That's why I'm skipping the definition of survey method. This is a checklist. Please kindly take a screenshot if you need. This year textbook, this year checklist is available in the book of Creswell JW 2008. It's the 5th edition. It is available online also. Even the third version, third editions also it is available, but the clarity wise is not be fine. Better to go with the 5th edition. Okay. And this here table, you can find the same as it is from the textbook, that particular book. He given a very unique checklist. Whenever you are going to plan for the research design for survey, your research design should give the answer for this much of questions. Then your research designs are very strong. We can easily come for conclusion. So this is a checklist for question for designing a survey method. So please kindly take a screenshot. The first one is the purpose of the survey design stated. In your third chapter, you have to pinpoint why you are adopting because in the survey method also we have the normative survey, exploratory survey, descriptive survey, like the different surveys. Kindly pinpoint which survey designs you are adopting and the purpose it should be highlighted there. And or the reason for choosing the design mentioned. So you have to pinpoint the reason to adopt the particular design. And the nature of the survey, whether it's a cross-sectional or longitude, that also should be highlighted. Your research design should give the answer for this. This is three things may come to the survey, basically from the methods. The survey method, in the survey, which the exact method which are going to adopt, these three questions give the answer for this. And this is for the population. And the sample up to this it's showing. So these 4 questions related to the sampling procedure and population. Is the population as is mentioned, as its size mentioned? Because generally, when I asked to my scholar also, suppose they are taking as a PG students, I asked them what is the population. So they told us, sir, I don't know the population. Then how you can select the sample size? It's a bigger challenge. So, and if you're asking my scholars, sometimes they will say, sir, I take the 500 sample, 600 sample, or 200 sample. I may ask the question, in what way you are selecting the sample? Then they could not find the answer for this question. That is should be ensured while making the research design, because we could not blindly take a sample size or random we are using the strategy, but we could not take the size of the sample as a random. So we can go with the 100 sample or 200 sample. We cannot go from our end. It's not at all correct. First, we must to aware of the population of the specific group. For example, I'm going to take a population of the entire Kerala PG students. PG students of Kerala. What I have to do, I have to go to the government websites and I have to find the number of PG students enrolled in the 2020-21. So we can find the number of PG students numbers there. Otherwise, there is separate website that is called IQAC. So that yeah, just I'm going to show some of the websites to you. It will be helpful for you. So because these are the things you have to be ensured. Suppose if you type IQAC, ISO, okay. ICE report. So every year they given this kind of report, or the government sector. So if you put the ICE report of higher education, so every year the higher education Minister of Education they're publishing it. So it's available in 1920. So very soon 2020-21. So every year it should be available. If you click here, you can find out the entire PDF file. This PDF file consists of the entire country. So in the Indian case, so whatever the Kerala, the number of colleges, number of, for example, if I go to the control F and put the Kerala, you can see the Kerala entire history or Tamil Nadu. If you go with the Kerala, wherever the Kerala is coming, we can easily find because just I'm searching randomly. So here we can see that the data. This is for the Kerala institution research for respondent of the ISO, and this is another one. This is for the Kerala based on the number of colleges per lakh populations. This is survey data report for specialization wise number of colleges. Then this is for the specialization wise number of colleges. This also. Yeah, just I'm going like this. Just yeah, this is a very high number. This is for the enrollment of private college students based on the actual responses. Private unaided college, private aided college, private total, government total. So everything we may get some kind of reports. Okay, these are the government's. This is called secondary data we have. So from this only we have to decide what is the sample size we have to go with this. For sample size calculator, what you have to do, you can go to the just you can type in the sample size calculator. But when you like to go with the sample size calculator, you should know the population. Without population, don't go with the sample size. It's not at all correct. If you go to the sample size calculator, we can find the plenty of sample size calculator. You can go with SurveyMonkey calculator or in calculator.net. If I go with the calculator.net, it is asking the find the sample size. That I already mentioned that you should be know the population size. For example, I'm taking the consideration of the only the Kerala, only the Kasaragod, only my district. There is 6 colleges, B.Ed colleges. I'm taking the samples of B.Ed colleges, 600 B.Ed colleges. Each colleges 100 students are there, for example. Therefore, 600 students in the Kasaragod district. So that is a population. Suppose I like to go with the confidence interval of 95%, or I like to go with the confidence interval of 99%. Margin error, I like to go with 24%, right? Then population proportion 50%. If you like to keep it, or 25, you can change it. If you go to the calculate, I can find the sample size 381. So it seems the 99% and 4% error. I can collect out of 600 381 sample. Suppose I like to reduce the error up to 1%. I like to reduce the error. So if I go to the calculator once again, I can find the sample 580. So therefore, before attempting fixing their sample size, kindly you must know the proper population. Suppose there is a 6,000 or 60,000. For 60,000, we can see how many sample size is needed. For 60,000, 13,028 students are needed. For the 4% of the error, we need 1,023 samples. So these are things how we can find this is based on the population. You should be aware of the population. The researcher, first thing you should know the exact population. You can use some kind of secondary sources because lot of secondary sources available, particularly for the this kind of higher education. So similarly, if you are belongs to the social work, you can find some of the government sector, they have some kind of data. You can approach them. Okay, so you may get the thing. Similarly, there is the other website that is for SurveyMonkey. That's also good. The sample size calculator. I'm going to this. So you can click the get started, or you can type directly here. The population size, for example, the same 600 students for BA. I'm typing 600 BA students of Kasaragod. I am giving the margin error of 4% and confidence level is 99%. So for me, 381 samples needed. Suppose 6,000 participants, 6,000 population, for that 887. For 60,000, I needed 1,023. I needed 1,023. Okay. So these are things we need. Yes. So there is a power failure. If anything is happened, can you inform me? Okay. Yes. So hopefully you understood how we can go with it. Just I like to go my presentation slides now. Yes. So here, the checklist which we discussed up to now, this one only. So just I like to go with pen. The first three things related to the survey method. Okay, these four things come under the sampling procedure and population. So is the population size mentioned, the population stratified, or whether you are going with random sampling or a non-random or a stratified or in a cluster sampling, that we have to give proper meaning in that. How many peoples will be there is a sample. So whether you are using the random sampling, non-random, these are solution, or these are the answers you may highlight in your result designs. And the next one is the instrument. Actually, these things come to the instruments, these three things. The instrument is nothing but tools. So what the instrument will be used for the survey, whether you are going to use the survey, suppose I like to ask some basic question, kindly give the answer. Suppose my intention to conduct a performance test. So I'm conducting an experimental. I like to check the achievement of the students, which is a tool I can use it for measuring the achievement of the students, which may be a correct tool. Which is the name of the tools we have to use it? Anyone kindly type in the chat box. My intention to prepare a achievement performance. I like to measure these students. So can I go with a questionnaire or a test, or can I go with a scale? Which is more relevant? Which is relevant? Yeah. Test on this subject. Yeah, specific subject. Yeah. Suppose I like to check the subject of mathematics or the physics, chemistry. Yeah, exactly. That answer is correct. The test. Achievement, it's related to test. Suppose I like to check the awareness of e-waste management. Which is a more relevant tool? E-waste management. Awareness. So that main term which I'm using for awareness. Which may be a correct one? Exactly, Subhashini sir. It's a questionnaire. Thank you. Suppose I like to check the perception of my students related to the augmented reality. So I like to check the perception or exactly the scale. Exactly, it's a scale. So yeah, Likert scale. Fine, it's a great Subhashini. So based on the variable which you are adopting, you have to sign, because even if I ask some question to my scholars, sometimes, okay, it's not happened now. When they joined that time, when I asked the students, different types of tools. Okay, so they could not, for all the tools, they may use the term as a questionnaire. Because generally the people's having the wrong idea that questionnaire is a common terms for all the tools. If you're asking about the attitude, if you're asking about the performance, any times they can tell the answer is a questionnaire. Because the questionnaire is a term, it's may only suitable in the case of awareness or some specific variable will be matched. So that should we have the awareness in that. 1 minute, I just try to connect the other system. Yes. So here what the procedure will be pilot study. So because when you go preparing any tool, we should go for the standardization procedure. There we have the pilot study, reliability analysis, validity. These are things we have to do. So this is also you can pinpoint the answers in your research designs. So therefore, these three questions answers should be there. Then the time limit of the admission surveys. So even there's a recently one of my scholar, not my scholar, my department scholar, he presented the PhD pre-submission. He present the pre-submissions. He attempted the experimentation. So he using some kind of life skill strategy. So the problem for him, I found from him, he go for the intervention or the teaching only for 20 days. Is it fine to go with a PhD for 20 days? Administration of the experimentation is 20 is enough for the experimental method for the PhD level. I'm talking about the PhD level. Anyone can. Yeah, of course, exactly. The Subhash method, at least 6 months he did it. But when he highlighted only the 20 lesson plan and he told that 20 days I went, I did the intervention. It's totally is to be wrong because you are not going with the proper timeline. So the proper timeline should be highlighted. Even we can easily to know whether the research scholar he attempted the research proper manner. From this way we have to easy to ensure. So don't even I found that some other people they're using only 10 lesson plan. They highlight that, so I use for the 10 days for intervention for the PhD level. How it's possible? So even they could not add. If you go with 30 lesson plan, it's not a relation, but you have to tell them 30 lesson plan. Each lesson I use for the 2 days. 1 day for the lesson transition, other days for activity. Either you can give some kind of justification for the 60 days. In what way you did the attempt. That is called timeline. The timeline should be clearly mentioned in the case of research design. You should be pinpoint that things. Yes, I'd like to ask, know the questions which you asked from your end. Yes, the next thing, what are the variable of the study? So even I found some of the research things. They have the confusion what is the independent variable, dependent variable, what is the confounding variable, what is called intervening variable. Lot of confusions they have. So because they are not aware of it, what is exactly variable and how we can measure. This is a problem for them. So they have to be aware of this kind of things. Yes. So the next thing, the variables. So these are things come to variable. Then data analysis. When you're talking about data analysis, which are the data analysis most suitable? Which are the things we have to control? The response bias, how to control. For example, when you're doing the data analysis, first we have to check the outliers. I found most of my scholars they're finding the outliers through the different analysis or the diagram representation. We can do the outliers. The outliers means, for example, there is 1,000 participants. Some participants, no, they give always see a high mark. Randomly, some participants they always give you a lowest mark. So therefore, automatically there may be exactly the Subhashini Ram. Thank you so much. So we can use the box plot or QQ plot. We can use for the what is that? Whether it's satisfying normality, we can use the QQ plot. Normally, the box plot we are using for the this one. What is this? Outlays. Or we can use the one more diagram that is called as here. There is a tree, stump leaf tree. So stump leaf. So there is a that from this also we can find this kind of outlays. These are things we have to check. Yes, even the scatter diagram is only meant for the correlation. No? Scatter diagram for the correlation, right? For checking the normality, we can go with this kind of stem leaf or the box plot. QQ plot for the normality analysis. So thank you, Subhashini Raman. Yes, then conduct a descriptive analysis, whether we can go with a descriptive analysis or inference, that we have to ensure that we have to highlight it and collapse the items of scales, check the reliability scales, what are the inference statistics is permissible, and how will we interpret. So suppose I have the questions, you can give the answer in the chat box. So some of the, in my research, I'm using both the t-test and chi-square test. Is it possible to do t-test and chi-square? Some people blindly told that you cannot go with this like this. Even I cross some other people, they may tell that how we can go with the t-test and chi-square test in a single research itself. So how we can tell like this? Actually, that is a problem for the researcher side. So based on the variable which are added, for example, I have the two variable. One variable is a gender, other variable is a level of emotional intelligence. The level of emotional intelligence is a order, like a ordinal form. And my gender also is a nominal. So I have the two variable. I like to check whether my independent variable gender having any kind of association with the emotional intelligence level. So what you have to check first, whether the both a variable in a quantitative nature or qualitative nature. So gender is a category, as well as my emotional intelligence also level, like a low, moderate, high. Therefore, for this case, I can do the chi-square only because I have the two variable. First variable gender also is a category. The second variable emotional intelligence, that also in the case of category. For example, low, moderate, high. Therefore, if the two variables are categorical in nature, then we can go with chi-square. Suppose in the case, instead of a low, moderate, high, you have the scores of the continuous data. Suppose your dependent variable is a continuous nature. Your emotional intelligence, there is no level. Instead of that, there is a mean score. You have the total mean scores you have. You have the continuous data set. Then what you have to do, you can go with the t-test. So based on the variable which you're selecting for attempting the research, you have to decide what kind of statistic process we have to go. So that is, we have to design, we have to fix during the research progress itself. Okay, that is why during the hypothesis itself, during the objective itself, we have to find this kind of things. So there is a question from numeric quantifiable data we can use for the t-test. Yeah, exactly. So your dependent variable should be continuous. So for the t-test, the basic assumption, your dependent variable should be a continuous nature. Your independent variable should be a categorical, but only the two classifications like male and female or Hindu, non-Hindu, or a rural, urban. Only the two classification. But in the case of the dependent variable, should be a continuous. These are the basic. I hope you now you understand the research designs of survey method. When you're thinking about the survey method, kindly give the proper answer or the proper reasons or proper what is that reasons or the answer for this much of checklist. If you are giving the proper things, it should be the very strengthened research design made it. Right. Similarly, there is a these are things I'm skipping because we don't have time at all. Generally, we have the research design having the instrument, sampling designs, and variable. These are three important things which will be interlinked with each other. That's why how we can select the data analysis based on the instrument, based on the sampling, based on the variables. Everything is to be influenced by fixing the data analysis. In the case of group, this is statistics. Just I'm skipping it because we don't have time at all. This for the experimental method. I hope the experimental method in the future or more section also there. This also the experimental procedure. The list. Just I'm skipping this. I'm moving. This or the some of the research design. If you need, I will share the PPT. These are the design, pre-experimental design, single group design. This was the quasi-experimental design, the two experimental design. This is another picture representation of designs of the experimental method. And these are the threads of the experimental design. Now I move to the qualitative. So in the qualitative, we discuss only the survey, but in the future, you have one more section later, the experimental method. That's why I skipped. In the case of qualitative, we have the different method. I'm not talking about the basic of qualitative. I'm just focusing on the research designs only. The phenomenology, case study. These are the method, ground theory, ethnography, and general qualitative. These are the data collection procedure. These are the qualitative data analysis methods. Normally, there's 6 steps of data analysis. Here, a lot of trimmings should be needed. The coding procedure should be much concentrated in the case of qualitative. These are the triangulation procedure. Yeah, so that's why I use the Creswell. So the image which I use, the things everywhere is available in the Creswell. So I'm giving the citation also. So this is citation of the Creswell book. You possibly can find it from there. Okay. It is available in the net sources. All the image, the picture represented they're given, even they're given as a checklist very clearly. So one of my favorite book is Creswell. So I'm always using this one. So this was checklist for the qualitative procedure. Some of the things may match. Some of things directly match with the quantitative, but some of things it won't be matched. Okay, for example, there we are talking about the survey method where you're adapting the specific survey. Here we are talking about what is the specific qualitative research design you are adapting, whether you are going to historical, social, cultural experiments, which you are going to adapt. And the sampling strategy, normally in the case of qualitative, we are using the non-randomizations. For taking the non-randomization, kindly highlight the things. How to sampling of patient design institute of students if there is a less number of population? So if the population is very less, then you can decide, okay, you can type the, suppose based on the what is the research design which you are going to adopt. If you're qualitative, only few samples enough. If you are going with the quantitative, you can need at least what is that? The 95% confidence level, just you can go with the tool which I show you. From this, you can find, for example, there's a 10th population. You can find the number of samples which you need for through that kind of sampling calculator. It may give the correct answer. Right. For example, if you like to go with some kind of special children, we cannot find the special children. We can go with this kind of sampling. It's for the judgmental sampling. some of these sample, you can think about the judgmental sampling also. Whether we can go with this random sampling and non-random. If the sample population is so high, you can go with stratified or random. If the sample is very limited and only if you're taking that particular sample, only your research may be fulfilled, you can go with this judgmental or judgmental sampling or a purpose sampling. Suppose if you like to take it's a sample for the sample is not much available. For example, I like to take the sample of this one. Now, what is that sample? There is a snowball sampling. Suppose I need to get the data from the transgender. So, but I know only 2 or 3 transgender of Kasaragod. Then what I have to do, I have to approach them. I can first collect the 2 sample from the transgender. Then after that, I can approach to them to find the other transgender from the other district. So they can give me 2 or 3 members. From them, I can connect with the 2 or 3 transgenders. So this is a way we can go with a very big buzz. That's called snowball sampling. So when the sample, it's not much high, the population is very limited. Kindly think about the this kind of non-probability and kindly find whether we go with purposely or convenience or snowball sampling. That's up to the researcher. And you can discuss with your guide and then you can do it. In the purposeful, that's why they use the word purposeful sampling strategy, right? Because the qualitative normally they use the purposely. So normally the tribal communities, if you are picking the tribal community as your research title, it's automatically judgmental sampling. Because once you take the sample as a tribal only, you can lead it further, right? Because then only your research may be fulfilled. So automatically come under the purposely one. There you can think about in the purpose how we are going to collect it. That's you have to think about different phases. The first phase can go with the purpose. In the second phase, how many samples in what we are going to collect, that you have to discuss with your guide. And then I think there is a separate section for the sampling. No, it's there. Kindly check. Okay, because my area is not that one. Research design. If possible, I will share you that PPT I'm having. Yeah, of course. There is a question. Shubhashini, under the purposive weekend system, we can do it. That's only the things I have to tell you. The researcher can check the feasibility. If you go with a very big thumb rule, we cannot go with we cannot finish the research. So the researcher having some kind of do some flexibility, but only the things kindly check the feasibility. That's why I'm always suggesting my scholar kindly check the feasibility of do the research. They are having a lot of idea to do the research, but it's not able to materialize. Kindly fix your specific objectives, kindly go with a specific sample, then you can go with it. Otherwise, they could not finish the PhD. So kindly check the feasibility and then go with the particular process, right? Because in the Vivos, you are only give the response. So if you're giving the proper justification, it's enough. Or the specific data collections and the protocol data analysis, the data needs to be different. So in the qualitative data needs to be different. So here the data coding is to be very much important. That's why I told that the data coding, here the coding, so there is the initial coding stage, second coding stage, third coding stage. And finally, we can present the findings. So a lot of coding stages should be involved in the case of check normally qualitative, because normally in the qualitative, there may be a bias. There is a chance the bias may come. That's why we have to collect the data properly. Otherwise, the bias becomes such. We have to limit this kind of bias through this kind of some kind of triangulation strategies we have to adopt. And we can go with such. Sometimes we can go with some kind of table representation. It's based on the data sets. Then have the basis of interpretation analysis base specified. Has the researcher mentioned the outcomes of the study? Are the multiple strategy cited? That's called validating of the finding. This is nothing but the triangulations. So the triangulations, you should give you a proper explanation of that. These are the checklist question. You should find the answer in your research design. So these are the research design questions on checklist. You have to locate on this. These are some of the observations. In what way we can do the observation in the qualitative. So it's a very good book. So they given a different observation techniques, documents, how to observe it, the audio visual material, how to observe it. They given different things here. Kindly look at. Then there is another method is my favorite method is mixed method. Even for my PhD scholar also, I told her you can go with the first phase as the experimental method as a quantitative. The second method you can go with the 3 or 4 case study you can do for the experimental group. You can just use some kind of interviewing and can write as a report. So that kind of things called mixed, because in one phase we can use the what is that quantitative, the other phase we can use the qualitative. But the names of the mixed method to be differ. First, I like to explain that one. After that, I come to the checklist. That is the first one is called convergent parallel mixed method. This diagram also is available in the same textbook. So one is called quantitative. This is called convergent. So we can the same phase. For example, there is a phase one. The phase one, it should go with the parallelly. In the one side, you can go with the quantitative, otherwise you can go with the qualitative, right? Otherwise, one side, the phase one, you can go with the stage one side is a quantitative. Otherwise, you can go with the qualitative. Then you can compare the two relates the result and finally get the interpretation. So it seems that both you are adding together, right? Quantitative plus qualitative. So you are keeping the consideration both. And the term QA in a capital letter. So whenever you are using the capital letter, it's called dominance. If you are using the small letter, there is no dominance. The particular methods is not much dominant. It's a lower dominance. So the capital letter is called high dominance, the lower letter for the small dominance, the lower dominance. So in this case, we can use both qualitative in a dominance base. So you can use the proper level, 50%, 50%. And there is the explanatory. So the term explanatory and sequential means we could not use both at the same time. Instead of that, we can go with the sequence. The first phase, for example, phase one. The phase one, I can use this one. The phase two, I can use this one. So the first 30 days, I can go with the quantitative. After 15 days, after the follow-up, I can go with some kind of quantitative for 15 days, qualitative. So the explanatory means the first phase, quantitative is high. See, the main dominance, the dominance of the result is in quantity is much important. For example, I'm using the 70% of the quantitative, only 30% of qualitative, then it's called explanatory sequential, because the first phase I'm using very dominant quantitative method. In the second phase, I'm using very little qualitative phase. So there it is called as a explanatory sequential. Sequence mean order, phase one, phase two. Then the next one is called exploratory sequential. So here what we have to do, exploratory means the first phase you can go with the quantitative. So it's qualitative. The first phase you can use the qualitative. Here 80%, for example, 70% you can use the qualitative, 30% of quantitative. For example, I'm listed here. So only the limited or only the lower weightage you can give for the qualitative. So quantitative in the case of exploratory. So in the explanatory, the dominance, so we may write like this: quantitative QUAN and one error mark and QUAL small letter, right? So it's a small letter. This is a small letter. It's a capital letter. This is called explanatory. Suppose I'm writing as a QUAL capital letter and one hyphen, and you are writing as a QUAN. It is called exploratory sequential. This is called sequential. If I use the term plus, it's called convergent. And there is a one more method is called embedded. Embedded means we don't have a different phase one, phase two. There is no step one, step two. We can blend both together at the same time. We can go, for example, I'm collecting the data quantitative, parallelly I'm collecting the data from the same sample qualitative also. I'm collecting both together at the same time. That's called embedded. So we cannot divide the things separately. You can collect the data at the same time into both the qualitative manner as well as the quantitative manner. And see here the qualitative or qualitative. Here also there is a things qualitative or quantitative data analysis. We can use both quantitative strategies. So here they can use the quantitative or qualitative, or qualitative data analysis, quantitative or qualitative. So like this they embedded. So it seems that in a quantitative you can use the qualitative. This is called, for example, there is a superset, right? I'm using this superset. My main focus is called quantitative. For example, I'm using more quantitative. In the quantitative, I'm just to use very limited qualitative here. This is called nested. Sometimes we may call it a nested. So here the qualitative nested into the quantitative. So because which is more power here? Quantity is more power. So the quantitative is more power. The nested into the so normally the term we can use this one is the first. The qualitative one we can, because the things which are using very less we can highlight first. qualitative nested in quantitative. Suppose I'm using different. I'm using the qualitative is a much flavor, and I'm using a very small amount of quantitative. Then it is called quantitative nested qualitative. This is called embedded. There's another one is called transportive mixed method. These are the methods I'm listed here. Then convergent exploratory. Here we can use all convergent exploratory. You can use the different phase. We can use it. This for the multi-phase mixed method. One case we can go with qualitative, then quantitative. Then we can go with the different phases, right? You can go with the 3 phases with the mixed method, but in a different way. This example is easy to find. So this is called quantitative to qualitative. This is called, I already mentioned, no? This is called explanatory, quantitative to qualitative. This is qualitative to quantitative, that is called exploratory. This is called convergent, that's a plus, is convergent. This is called nested, that is, I told us the embedded one. So here the quantity is much high, qualitative is very less. Therefore, what I call qualitative nested into the quantitative. So the quantity layers are so high, only qualitative you are using less. So here they're using the different symbol also. E symbol having the meaning. Just I show the symbol also. If you are using the uppercase letter, it is called greater emphasize. Lowercase is a lower emphasize. The plus symbol for the convergent, ARMR for the sequential, bracket for the embedded. For example, in this case, qualitative nested quantity. Qualitative nested quantity. It seems that quantity is a very big layer. In the inside, qualitative very less. So that is called qualitative. This is called recursive. Sometimes it will be opposite. This is called steady within a series. That's called multi-phase. So this way, the symbol having the meaning, unique meaning. So we have 3 minutes time. Just I like to show the checklist. Okay. So here there is a checklist for ensuring your mixed method research design. Kindly check whether your research design satisfying or giving the answer for this kind of questions. The basic definition of mixed method research is provided. And what is the reasons to use the both quantities? Because some people unknowingly they are using the quantity quality. So mixed method, if you need, then only you can use. Otherwise, don't we go. Okay. Some people for unwanted, they're using what is the unnecessary data analysis, some unnecessary what is the designs and all. So kindly check the particular topic is need. Then you can go with this kind of things. And other criteria identified chosen mixed method. The mixed method isn't identified because sometimes you can go with conventional, sometimes you can go with we can feel that the exploratory might go. Sometimes you may feel that what is that exploratory compared to the explanatory is to find, or sometimes you feel the embedded is to be fine. So you have to give the reason for this. Then visual model, then proper notations, visual mode you have to give the, and where you are, which is sampling. So for example, you are using both strategy, quantity and qualitative. So in the quantity, which is the sampling strategy used? In the qualitative, which is the sampling strategy used? So you have to mention this. And or the procedure validated, whether the procedure which you selected, it is designed and validated by the quantity and qualitative research. And narrative structure of the final decisions or thesis mentioned, does it relate to the type of methods being used? So for all the questions, your research doesn't give the answer. So this is called mixed research. So I have the different slides, like what is called variable, because it's part of the things, what is called variable, independent variable, dependent variable, and how the control, what is called control confounding variable, mediating variable, moderating. Because I don't have time, just I'm skipping the slides because I like to give the variable meanings. Then after that one, I like to go with this design, but we don't have time. That's why I started directly to the design. So these are the basic things you must be aware. Only one suggestion I like to go because even I found lot of students what they doing the mistakes whenever they plan to go with the scale, even it's for the satisfactory scale or a survey or in a qualitative or the importance or in a frequency. Every time they are going with the same terms, strongly agree, disagree only. Please request the scholar. You can check what is the exact things you are going to measure. Suppose you like to measure the quality, you can go with very good, fairly good, neither good. If you are going to check the importance, go with a different scaling pattern. Scaling only 5-point scale, 3-point scale, but the term which you are using should be different. Suppose you like to check the interest or the opinion, you can go with a different way. So if you are using the satisfaction, you can use the different terms. If you are using the frequency, normally this good in the case of usage. For example, you are checking the ICT usage or the e-learning usage, you can go with this kind of frequency all of the time, very often. Truth, attitude scale. And one more thing, if you like to go with the novel way of the research, I request all to use this kind of emoji or star rating scale, because I'm using regularly for my peer scholar, MS scholars now, this kind of scaling. Instead of going with a normal scaling of, I strongly agree, you can go with this kind of novel pattern. It will be good for you. Just I'm skipping this. Yeah, so just I'm coming to the, because this slides consist of the validity related process. So I'm sharing this PPT, don't worry. And at the end, I'm sharing the PPT to the madam. So madam share to the PPT. So here, she's asking the how we can check the outlays and all. So here the diagonal representation also available. Yes, just I'm skipping this. Yeah, now I like to share the thanks to this much of people first, because first of all, I share the PowerPoint for my share and Zoom, because from this only I'm connecting with you. And thanks to all the tools which I'm used for collecting these materials. And I like to quote some of the acknowledgement to the human being. Particularly, I referred the book of Creswell. I found a lot of things from that. So thank you so much, the particular author, to provide such a wonderful material for us. And other textbook which I refer. And thanks to the organizers, special thanks to the all the Annamalai University faculty, and special focusing on the Pravina madam. She's given welcome address for me, as well as the Sai Lilana. Thanks to my teachers, especially for Borders University, my guide Mitsami sir, Sindhinadan sir, and Ramkani sir, and other teachers, and other teachers those are supporting me. Thanks to entire participants for a patient and active participation. Thank you all. So there is a question from Subhashini Ramanan. Is there possible we can combine? Of course, that's right. The constructivism and positivism, if you're merging, it's come to the pragmatism, right? So constructivism is purely based on qualitative. Positivism purely based on quantity. If you're merging, automatically it's a mixed method, then you can lead the pragmatism way. Pragmatism. Okay.
Thank you, sir. Thank you, sir. Now I invite Dr. K. Pravina ma'am, Associate Professor, to propose thanks for this session. Ma'am, please. Pravina ma'am, please. Yes, ma'am. Now you can speak. Now you can speak. Pravina ma'am.
Good evening to all of
Pravina
you.
ma'am.
Can you hear me?
Yes. Yes, ma'am. Yes, ma'am. Yes.
Good evening to all of you. I hope you had a wonderful session on research design. Sarah has explained clearly the three approaches to research: quantitative, qualitative, and mixed methods. He has listed out the characteristics of research design. He has given us the checklist. Moreover, he has through insight on DASH report, sample size calculator, emoji rating scale, and pictorial representations of scale, which was really new to some of the participants. Thank you, sir, for your valuable session. I hope the participants were highly benefited. Thank you, sir, for sparing your valuable time and with us and sharing your expertise. Thank you, sir.
Thank you so much.
Thank you so much, sir. Thank you, Satyagu, sir, for accepting our invitation. Thank you.
Thank you.
Ma'am, kindly introduce our next session resource person, ma'am, please.
Yes. Good evening to all of you. I'm happy to introduce Professor Chaudhary. He's well known in our this 2 weeks workshop, but still I deem it a pleasure to introduce him. He's the Associate Professor of Statistics from MG Science Institute, Ahmedabad. He is a very experienced professor. For the past nearly 3 decades, he has been serving as a teacher in statistics. Throughout his educational career, he is a gold medalist. He is knowledgeable in using statistics softwares like R programming, SPSS, Minitab, MS Excel, then Python programming. Is providing consulting services to Inflibinet at Gandhinagar. He has served as a resource person in nearly 50 programs. Such a resourceful person is here to address the session with today to deal with Anova. Sir, on behalf of IQAC, I welcome you, sir. The session is yours,
Good evening, sir. Good evening, sir.
Good evening. Thank you, Pravina madam.
Thank you.
Shaila madam. It is a really a great privilege for me to deliver more sessions during this workshop. This today's session is about analysis of variance using SPSS. So in earlier sessions about SPSS, you studied about sorry. You studied about the hypothesis testing, parametric hypothesis testing, right? So actually analysis of variance is again a parametric test. So there are various parametric tests for testing the population parameters. There are some non-parametric tests also. So we will discuss non-parametric test in tomorrow's session. In today's session, I am going to cover analysis of variance, one-way ANOVA, two-way ANOVA. Actually, what is analysis of variance, how it is used and when it is used, and how to perform analysis of variance in SPSS. So that is my main goal in today's session. So just wait a minute, I will share my presentation. Okay, so as you know, in parametric test, basically we are interested in testing the population proportion, the population mean, the population variance, single, or we might be interested in testing difference between the two proportions, difference between the two means, difference between the two variances. So in all these circumstances, we use parametric test, right? And again, if you want to compare more than two groups, if you want to compare means of more than two groups, means of more than two populations, then also we can use a parametric test. Earlier, you studied the t-test, one sample t-test, independent sample t-test, then dependent sample t-test. And here in today's session, I'm going to cover analysis of variance. Basically, it is also known as F-test, because t-test assumes the distribution of the test statistic in t-test is a student t distribution. In analysis of variance, we use Snedeker's F distribution. So these are various distributions. Basically, in hypothesis testing, the four distributions are very, very important. The first one, that is a standard normal distribution, Z distribution, what we call it as. The second one is a chi-square distribution. Third one is a T distribution, and fourth one is F distribution. So basically, in hypothesis testing and statistical analysis of qualitative or quantitative data, these four distributions plays a very, very important role in analyzing the data. So in analysis of variance also, we have to compare means of more than two groups. Under such a situation, we can go for analysis of variance. One more interesting thing is parametric tests are applicable only if certain assumptions about the population or the population distributions are satisfied. Then only we can go for the parametric test. Otherwise, if the assumptions of the t-test or assumptions of the independent sample t-test or pair t-test or ANOVA test are not satisfied, then it is meaningless to use these tests for such a data. So when the assumptions are not satisfied, we have the alternative way of analyzing the data, and that is a non-parametric test. So in tomorrow's session, we will discuss the difference. We will discuss about the So actually in today's session, I am going to cover what is analysis of variance and what is actually purpose of analysis of variance. One-way ANOVA, that is ANOVA is a short notation for analysis of variance. Then in one-way ANOVA, how to perform the post hoc analysis, that is known as a pairwise comparison. Then we will discuss with the help of one example how we can perform one-way ANOVA in SPSS. Then the next is about two-way ANOVA. We will see what is two-way ANOVA, what is one-way ANOVA, and pairwise comparison, that is a post hoc analysis in two-way ANOVA. And with the help of some example, we will discuss about the two-way ANOVA. Okay, so actually in statistical studies, there are two types of studies. One is observational studies and another is experimental studies. So in observational studies, whatever the data we have, that is based on the past data, based on the observed data, we can draw some conclusion about the general mass or about the population, right? So for example, here workout, whether that workout increases the energy level or not, and when the persons do not work out, then what is the effect of that on the energy level? That means, is there any significant difference between the average energy level due to workout and due to non-workout, right? So this is based on the past data, observed data, right? But in experimental study, a researcher conduct an experiment and try to check the influence of some factor variable on the dependent variable. Okay, so actually this is observational studies. So researchers observe only what is happening and what has happened in the past. So whatever the data we observe, just by conducting a survey, we collect the data, right? So that data is nothing but the observed data, and based on that data, we try to draw some conclusion based on the observation about the whole scenario. Some examples of the observational studies are smoking habit, effect of the smoking habit on the stress level of the people, right? So some people are light smokers, some people are moderate smokers, some people are heavy smoker. So when we collect the data about the stress level and their smoking habit, so that is observed data. When we conduct a survey and we collect the data about these two variables, stress level and smoking habit, so this is the observed data. Researcher is not conducting any experiment, right? So it is simply the observed data. Same is the effect of tea and coffee drinking habits on the blood pressure. So these are some examples of the observational studies. In experimental studies, researcher control one or more factors and observe the influence of these factors on the variable of interest, right? And based on that, researcher tries to draw a conclusion about how this factor influences the variable of interest. For example, the in pharmaceutical industries, researcher test different dose level of drugs to treat certain disease, and at the end they collect the data about the recovery from the disease. So in this case, researcher actually conduct an experiment, right? Researchers select some respondents, some patients suffering from that particular disease, right? And they divide it into some groups, and for one group they give some dose level, for another group another dose level, third group third dose level, and collect the data about the recovery time or whatever the variable of interest. And such a experiment, such a study is known as experimental study. Similarly, the agriculture researcher wants to check the effect of different fertilizers on the yield of the crop. So here different fertilizers are the factors which influences the yield of a crop. So this is again the example of experimental study. Similarly, effect of various teaching methods on the performance of the students. Say, for example, we want to check the effect of different teaching methods. One is self-study, another is chalk and that is a classroom method. Another one is by using the PowerPoint presentation or online teaching, right? So we can check this by conducting an experiment for some different group of students, right? So these are some examples of the experimental study. And analysis of variance technique can be used to analyze both type of studies, whether it is observational studies or whether it is experimental studies. One can use analysis of variance test. Okay, so what is actually analysis of variance? So analysis of variance is nothing but a procedure for testing the difference among different group of data for homogeneity. Now here the word homogeneity is in terms of their center, that is in terms of the mean, whether the groups are having same mean or there is a difference in the means. Okay, so basically it is a statistical method to test difference between two or more means, right? So we have in day before yesterday's session, you studied about one sample t-test, two sample t-test, dependent sample and independent sample. Actually, dependent sample and independent sample test, t-test, are nothing but the test to compare two groups, right? Whether dependent groups or independent groups. So in that case, we want to compare mean of two groups, right? But when we have to compare more than two groups, then the one alternative is we can go for pairwise t-test, right? Say for example, I want to compare three different fertilizer, effect of three different fertilizer A, B, and C on the yield of a particular crop. Okay, so obviously we can collect the data either by performing the experiment or by observing the data, right? And then we can compare fertilizer A with fertilizer B, fertilizer A with fertilizer C, and fertilizer B with fertilizer C. That means for this comparison, for this one experiment, we have to conduct three separate independent sample t-test. But the problem is when we apply pairwise comparison using a t-test, the power of the test reduces, right? The power of the test becomes minimum, that means small power. And that is why we want one technique in which should be more powerful than the pairwise comparison, and one such a technique is analysis of variance. Okay, so actually the name is given as analysis of variance. The technique is known as analysis of variance rather than analysis of means, because the reason is the differences between the group means are compared. Actually, our aim is to compare the hypothesis that is there any significant difference between the means of more than two groups that we want to compare. But the hypothesis about the difference between the means that can be tested by analyzing different variances between group variances, right? So that is why it is known as analysis of variance. That means comparing more than two groups, comparing means of more than two groups by analyzing the variances. So it is known as analysis of variance. So Anova technique is given by Professor R.A. Fisher, who is nothing, who is a popularly known as father of statistics. Professor R.A. Fisher gave so many different statistical methods. So Anova is one of them. The main objective of Anova is to separate out the variation. What is the variation? So if we observe any data, so there are two types of variation. One is variation due to some specific cause, that is known as assignable variation or assignable causes. And another is due to random component, due to chance component. So that is known as chance causes, right? So according to Professor R.A. Fisher, Anova is nothing but separation of the variation or separation of the variance from one group of cause from that of the another group of cause. So whatever the total variation in the data is there, so we wish to separate out the total variation, and we wish to find out how much is the variation due to assignable causes and due to chance causes, right? assignable causes and chance causes. Say, for example, in one particular class, teacher A is teaching one subject, right? So in that case, if we collect the marks of the students from that particular class, we observe the variation. Same teacher teaching the same subject, but still the marks of the students vary, right? So that is a random variation, right? Suppose in one class, teacher A teaching the subject, in another class, teacher B teaching the same subject. So in this case, what we have, so if you think about only class A, so in first class, there is a variation in the performance of the student. In the second class also, there is a variation, right? But if you look at both simultaneously, and if we observe the variation in the scores, we can say that may be because different teacher teaching the same subject. In one class, teacher A teaching the subject, in another class, teacher B teaching the subject, same subject. So it may be because of teacher, right? So when we use such a factor, that is known as, the variation is known as due to assignable causes. Due to different teachers, there is a variation, right? But in between, within the class, there is a variation that is known as a chance variation. Okay, so to understand this, let us take a very simple example. I have a data about 5 different brands of headache tablet, and these headache tablets are administered to 25 subjects experiencing fever of 38 degrees centigrade or more, right? And the number of hours of reliefs are recorded, right? So this is my data. Okay, so this is the data. So if we observe the data, it is clear that there is a variation from first column to second column to third column to fourth column, and so on. So it is clear that the variation is because different tablets are given for different subjects, right? So this variation, because of this different brands of tablet, there is a variation in the number of hours of relief in the data. So this is known as the assignable variation. But same tablet A is given for this 5 subject, but still if we observe the data, there is variation in the data. So this is nothing but the random variation, right? So this is how we can separate out the variation, right? So in one way, Anova, actually what we have, so here we have one independent variable, say for example, brands of tablet. So number of hours of relief depends on the different brands of tablet. So this number of hours of relief is a dependent variable, and different brands of tablet is a independent variable. Okay, so this is the same thing which I have explained, right? So here number of hours of relief, it is a continuous variable. It may be either interval or ratio type, but the brands of headache tablet, that is a categorical variable. It may be nominal or it may be ordinal. In this case, in this example, it is a nominal data, right? So according to Professor R. A. Fisher, total variation in the data is due to 2 reasons. One is due to assignable variation, another is due to chance variation. In earlier example, because of different brands of tablets are used, there is a variation, right? And chance variation, that is a random variation. Within tablet A itself, we have the variation. Within B, we have the variation. So that combined together is a random variation or a chance variation. So the basic aim is to analyze the total variation, is to split the total variation into component variation, and then we wish to compare, is there any significant difference between the average number of hours of relief due to different brands of tablet. Okay, so what is the basic principle? The basic principle of analysis of variance is to test the difference among the means of the populations by examining the amount of variation within each samples relative to the amount of variation between the sample. Try to understand this. Within each sample, there is a variation. Relative to between the samples, there is a variation, right? So total variation is, that is, one is a between variation, another is a within variation, right? So variation across the different brands of tablet and variation within each brands of tablet, right? So this total variation is split into two component variation. So this is the logic behind, basic principle behind the analysis of variance, right? Now there are different types of analysis of variance techniques. One is a one-way ANOVA. We will say what is one-way ANOVA. Another is a two-way ANOVA and n-way ANOVA. N-way means more than two components, more than two factors we have to study, then we can go for n-way ANOVA. Okay, so one-way ANOVA has only one factor. Like in earlier example, we have only one factor, that is different type of tablets, different brands of tablet. Okay, so that is one factor under study, right? One dependent variable which is of continuous type, either it may be interval or ratio, for example number of hours of belief. So this is a continuous variable. Okay, and one independent variable, it is always a categorical variable, right? So categorical variable with more than two levels, right? Why more than two levels? Because if we have only two levels, then we can go for independent sample t-test. But here we want more than two levels. For example, 5 different brands of tablet A, tablet B, C, D, and E, right? So in such a situation, we can go for one-way ANOVA, right? Two-way ANOVA, again, there is only one dependent variable and there are two independent variables. The dependent variable is always a continuous variable. For example, grade of students, right? So grade of students depends on two different factors. Say, for example, teaching methods, different teaching methods, method A, B, and C, and suppose school type. Say, for example, state board student, central board student, and ICSE board students, right? So here there are two independent categorical variables. One is a teaching method, another is a type of school, that means board. Okay, and only one dependent variable, that is a grade of a students, right? So we want to compare whether there is a significant difference between the average performance of the students due to different teaching methods or whether due to different school type, right? So this is two-way ANOVA. Okay, now in one-way ANOVA, as we have already discussed, one-way ANOVA, it is used to examine the difference between the means of more than two independent samples. Again, this more than two independent sample, that is important, right? We have a categorical independent variable, which is also known as a treatment. In terms of the design of experiment, it is known as a treatment. It should have more than two categories, and the most important, normally distributed dependent variable, which is also known as a response variable. So there are two types of variables. One is a dependent variable, another is a independent variable. So dependent variable is known as a response variable or outcome variable, and independent variable is known as predictor or explanatory variable, which explains about the response variable or dependent variable. Okay, so the objective is to test the difference between the means of the dependent variable across various levels of the independent variable. In earlier case, we want to compare the mean average amount of relief time due to different brands of tablet. Okay, so in short, one-way ANOVA is the extension of independent sample t-test. It is the extension. In independent sample t-test, we compare two groups, right? In ANOVA, one-way ANOVA, we compare more than two groups. So it is a generalization of independent sample t test, right? So this is a simple example. Suppose we have, this is my population for the tablet A, population for the tablet B, C, D, and E, right? Now here, from this population, for this population, the mean is, say, for example, mu1. For this, it is mu2, mu3, mu4, and mu5. Okay. Okay. And suppose from this first population, we have selected a sample of size 5. From second, we have selected a sample of 5. So we have a sample mean x bar 1, x bar 2, x bar 3, and so on, right? So here we want to compare based on the sample data. We want to draw inference about the population mean. So is there any significant difference between the number of hours of relief due to different brands of tablet that we want to compare? Okay, so this is the example which already I have given you, showed you that tablet A, there are 5 observations, tablet B, there are 5 observations, and so on. So this is the data set, right? Now, actually, what is a mathematical model? So the mathematical model for the one-way ANOVA is like this: Yij, that is observed response, right? Jth observation from the ith treatment or ith level of the factor variable. Okay, so Yij equal to mu plus alpha I plus Eij. Here mu is the general mean effect of whole experiment. Alpha I is the effect due to ith factor, ith level of the factor. Say for example, in our example, there are 5 tablets. So alpha 1, alpha 2, alpha 3, alpha 4, and alpha 5 are the effect due to the ith level of the tablet. Okay, ith tablet. Okay, and Eij, that is the error effect due to chance, right? Eij is the error effect due to chance. That is a random component. Okay, and the assumptions for one-way ANOVA that errors are normally distributed. These assumptions are very, very important. If your data does not satisfy this assumption, so it is meaningless to use analysis of variance. So we have to choose alternative method, right? So normality assumption is very, very important in almost all parametric tests. So errors are normally distributed. Errors have mean 0 because some errors are positive, some errors are negative. So overall, the expected value of the error equal to 0. Errors are independently distributed. That means observations are independently distributed, right? And errors have equal variances amongst the factor level, right? So there must be homogeneity about the variances, right? So these 4 assumptions are very, very important for analysis of one-way ANOVA, right? Now, what hypothesis we want to check? We want to check hypothesis about the effect of independent variable on the dependent variable. So effects are denoted by alpha i's. Okay, so all these alpha i's are equal, and that is equal to 0. Or you can write it in terms of the mean. Mean of the independent variable against the alternative hypothesis. So remember, in independent sample t-test, when we compare two means, your alternative hypothesis is either not equal to, or it is less than or equal to, or it is greater than or equal to, right? But in one-way ANOVA or in analysis of variance, whether it is one-way, two-way, or something else, right? So in analysis of variance, your alternative hypothesis is always in terms of the pair. That means at least one pair of alphas differs significantly. At least one pair. right? So you cannot say that alpha 1 not equal to alpha 2 not equal to alpha k, but we can say that at least one pair differ significantly. That means there is an effect of independent variable on the dependent variable. Okay, so what is the how to perform the calculation? So actually this is not that much important, but those who are interested, so total variation can be split into component variation, that is variation between the groups and variation within the groups, right? So this is known as the total sum of square. In short, it is denoted by TSS. This is known as SS due to different groups. Because we are using different groups, we are using different factors. So it is SS due to groups or SS due to factors. And rest of the variation is because of the random component, because of the chance causes. So it is sum of square due to error. So it is denoted by SSE. And these are the mathematical formulas to calculate various sum of squares or variations. Okay. So now for all these sum of squares, we have the degrees of freedom. In analysis of variance, there is a term known as the degrees of freedom. So actually degrees of freedom is nothing but number of independent constraint conditions to calculate that particular sum of square. Say for example, just try to understand one, you will get idea about the others, right? Say for example, the total sum of square TSS. So TSS can be calculated using this formula, that is summation I from 1 to n Yij actual observed value minus the overall mean and square. So it is nothing but sum of squares of the deviation of observation from its mean. Okay, so how many terms are used in this calculation? So I from 1 to n. Sorry, so there are n terms in the computation. Okay, and with one restriction. So this is that restriction. If we calculate for any data, if you calculate summation of Yij minus y bar double dot, it is always equal to 0. So this is the property of the arithmetic mean. Sum of the deviation of the observations about its mean is always 0. So this is one particular condition, right? So n terms are used in the computation with one restrictions. So for calculation of total sum of square, the number of independent constraint conditions equal to capital N minus one dependent condition. So that is n minus 1. So this is how we can use the degrees of freedom. Okay, this is the concept of degrees of freedom. Same way, we can have a degrees of freedom for sum of square due to group, that is k minus 1, because these k terms are used for the computation with one condition. This is one restriction. This is equal to 0. Here it is a typing mistake. This is equal to 0. Okay, so one condition, right? One restriction. So k minus 1 independent conditions are there. Okay, so that is why the sum of square due to groups carry k minus 1 degrees of freedom. And as we know that the model is the additive model. Additive in the sense the total variation is the addition of the component variation. So the degrees of freedoms are also additive. So if you put for this TSS, it is n minus 1. For SSG, it is k minus 1. So for SSE can be calculated as n minus 1 minus k plus 1. So it is n minus k degrees of freedom. Okay, so this is how we can calculate the degrees of freedom. Okay, so actually this is how we can compute, because computation, even though if we calculate the results with the help of software, one should know the basic behind the calculation. Okay, so the sum of square, so actually these are the sum of squares, right? And from the sum of square, we try to calculate the average sum of square, that is known as a mean sum of square. So mean sum of square due to group, that is sum of square due to group divided by the corresponding degrees of freedom, SSG divided by k minus 1. Same way for the error we can calculate SSE divided by n minus k. Now, these two quantities are very, very useful in analysis of variance technique, right? So after calculating all these results, we have to prepare the ANOVA table. In ANOVA table, the columns are fixed. Okay, the first column is always the source of variation, right? That means source of variation means the kind of variation. So we have the variation due to different groups or due to different factors, variation due to error, and finally combining these two will get the total variation. Then the degrees of freedom. So already we have seen how the degrees of freedoms are computed. So these are the degrees of freedom for different sources. Then sum of squares. So here we have to put the values of all these sum of square, results of all these sum of square, then mean sum of square. This SSG divided by k minus 1. So that is the mean sum of square for the groups. Similarly, SSE divided by n minus k, that is mean sum of square due to error. For total, it is not required. Okay. Now, after getting all this sum of square or mean sum of square, the next step is to calculate the F test statistics, on which we have to take the decision about the acceptance or rejection of the null hypothesis. Okay, so F is nothing but the ratio of, it is the relative variation, right? Ratio of MSG to MSE. So this is known as the test statistics. It is F test. That is why it is also known as F test. Okay, so this is the test statistics under the null hypothesis. It is MSG upon MSE. So when we put all these calculated results, you will get F observed values. That means the calculated values from the observed data. Okay, so this is the observed values, right? Now, as we know that this particular test statistics follows F distribution with k minus 1 comma n minus k degrees of freedom, right? So this is the Snedeker's F distribution. Okay, so this observed, this ratio follows F distribution with k minus 1 comma n minus k degrees of freedom. So we have to find out the critical value. That is, now there are two approaches in hypothesis testing. One is a traditional approach, that is using the critical value, we can take the decision about the acceptance and rejection of the null hypothesis. Okay, another approach is p-value approach. Okay, so in traditional approach, given the level of significance alpha and the degrees of freedom k minus 1 and n minus k, we can calculate the F table value, that is known as the critical value of F, right? If the observed data, this F observed is less than F critical, we fail to reject the null hypothesis at alpha level of significance. Otherwise, we reject the null hypothesis at alpha level of significance. So this is how we can use a traditional approach. Actually, earlier days, when it is difficult to compute the p-values, because p-values, for the calculation of p-values, softwares are needed. Okay, so earlier days, people, researcher use traditional approach for the for taking the decision about the acceptance and rejection of the hypothesis. Okay, so this is the graph of F distribution. Okay, so this is the alpha, that is the level of significance. Basically, we use 5% or 1% level of significance. Okay, so this is the area. Actually, alpha is nothing but the probability of committing type 1 error, or this is the area, right? So this red color area is nothing but the value of alpha. Okay, and along x-axis here, whatever the value of F we get, that is known as a F table value or F critical value, right? Now, whatever the observed data we have, F observed, so just check that F observed along the x-axis. If F observed falls in this region, right? Here, if it falls below this F table, sorry, above this F table, we reject the null hypothesis. If it falls below this F table, we fail to reject, or what we call it as an acceptance region, right? So this critical value, actually critical value divide the region into two parts. One is a acceptance region and another is a rejection region. It is based on the level of significance alpha. So this is the traditional approach, right? Now the p-value approach. Now instead of calculating, instead of obtaining the critical value, directly we can calculate the p-value, right? So whatever the observed f value we have, right? So calculate the probability that this f is greater than f observed, and that value, that area is nothing but the p-value. Now if p-value is greater than alpha 5% or 1%, we fail to reject the null hypothesis. Otherwise, we reject the null hypothesis. So this is a p-value approach. Again, graphically, so instead of given alpha, in earlier graph, given alpha, we try to find out ft. Okay, in p-value, we don't have alpha, right? We have the f observed value. So put f of observed along x-axis and try to find out this area. This area is nothing but the p-value. Okay, and if the p-value is less than or equal to alpha, reject the null hypothesis. Otherwise, fail to reject the null hypothesis, right? So this is the p-value approach, right? Now the next step, after getting the decision about the acceptance or rejection of the null hypothesis, either you reject the null hypothesis or you fail to reject the null hypothesis. What is your null hypothesis? All having same effect, right? All the factors are having same effect. Say alpha 1, alpha, say for example mu1 equal to mu2 equal to mu5. So all the 5 means are equal, against at least 2 mean differ significantly. Now suppose we reject the null hypothesis. That means the means are not equal. When the means are not equal, right? Means are not equal, it means at least one pair differs significantly. So we have to go for the post hoc comparison, right? That is known as a pairwise comparison. There are different techniques for the pairwise comparison. Okay, so there are different techniques for the pairwise comparison. Okay, what are the different techniques and when to use post hoc, right? So remember, after applying analysis of variance, if your hypothesis, null hypothesis about equality of means is rejected, then only we go for the pairwise comparison. If we do not reject the null hypothesis, then no need to compare pairwise. Okay, so when the null hypothesis about equality is rejected, then only go for the post hoc analysis, that is pairwise comparison, right? So for pairwise comparison, there are 3 different methods. Actually there are more, but commonly used method for the post hoc analysis, they are the Fisher's LSD, least significant difference. Another one is Tuckey's HSD, that is honest significant difference. And the third one, that is Dunnett's method, right? So the first 2 methods are used in practice regularly, right? But the third method is used only when we have one group that is a control group and other groups are treatment group. Control group in statistical terminology, it is also known as a placebo group, right? In medical terminology, it is known as a placebo group. That means without any treatment, right? Without applying any treatment, we collect the data, right? Again, on one field, we apply the treatment A, on another, we apply the treatment B, and so on. right? So placebo or control means without any treatment. Okay, so when we have control and treatment groups, right, and you want to compare treatments, all possible treatments with the control group, right, then only we can go for a donut test. Otherwise, if there is no control group and all are the treatment groups, then you can go for Fisher's technique or Takis technique, right? Both techniques are used commonly, right? So these are the different techniques, post hoc analysis for the pairwise comparison. Okay, so these are the formulas, right? And when the null hypothesis about equality of means for k groups is rejected, that means the means are not equal, then we are interested in ijth pair. That means mu1 against mu2, mu1, mu1, mu2, mu1, mu3, mu1, mu4, all possible pairs. Okay, so this is in general, ith and jth treatments are compared. Ith and jth factors are compared. Okay, so this is the formula for the Fisher's LSD test. Okay, similarly, this is for Takis LSD test. Okay, this is for Donut's test, right? So I'm not going into detail of the formulas. All these formulas are available in all design of experiment books. Okay, now the main thing, how to perform analysis of one-way ANOVA in SPSS. Up to this, we have discussed the theory of analysis of one-way ANOVA, different formulas, different techniques, right? Now, let us see how to perform one-way ANOVA using SPSS, right? So I am taking the same example, but let me show you. See, actually, this is my data, right? The most important thing, I think in earlier session also, that resource person told you about the coding of the data, right? So coding is very, very important while using SPSS, right? So if you look at this, it shows that there are 5 variables. Actually, these 5 columns are not the 5 variables. There are only 2 variables. One variable is these numbers, what this number represents. This number represents the number of hours of relief, right? These numbers represents number of hours of relief. Okay, so this is one variable. Okay, this is one variable Yij, observed data. Okay, and what is another variable? Another variable is 5 different brands of headache tablets. Okay, so brand of tablet is second variable, right? If you look at the table, it shows that there are 5 columns, tablet A to E. So there are 5 variables. So these are not 5 variables. There are only 2 variables. One is dependent variable, that is number of hours of relief, and second variable, brand of tablet, right? Either it may be A, B, C, D, or E. So brand of tablet is a nominal variable and number of hours of relief is a continuous variable, right? So if you look at the data, if you enter your data exactly same way in SPSS, it will not work. Okay, so that is why in SPSS, proper data entry, proper coding is very, very important, right? So how to enter the data, right? So before that, let us see, let us denote all these things. Okay, so as we want to compare the mean of more than 2 independent samples, okay, we use one-way ANOVA, right? And what is mu1? Mu1 is the mean hours of relief due to tablet A, mu2, mu3, mu4, mu5 due to B, C, D, and E respectively. Okay, so these are just notation. Now, what is the hypothesis? What hypothesis I want to test? That mu1 equal to mu2 equal to mu5, mu4 equal to mu5, right? That means there is no significant difference between mean hours of relief using 5 different brands of tablets. Okay, so this is the null hypothesis, right? As you know that null hypothesis is always about the equality. It is always about the equality. Okay, against the alternative. Now, since you cannot write mu1 not equal to mu2 not equal to mu5, right? We can write this way: mu I not equal to mu j for at least one pair I and j, right? Or we can say that there is a significant difference between mean hours of relief using ith and jth tablet. That means A, and you can take ij as A, B, C, D, and E. Okay, so this is how we can set up the hypothesis, right? Now the main thing is data, right? How to enter the data. Actually, as I told you, if you enter the data like this, 5 columns, so you cannot apply one-way ANOVA directly on this. Okay, so your data must be, actually there are only 2 variables in this particular table, right? So you, in SPSS also, you should have only 2 variables. The first one, that is hours of relief. Second one, that is the brand of tablet. Okay, this is my data view. If you look at the data, so there are 25, right? 5 in each category, right? In a variable view, you can see the label, that is hours of relief, tablet, that is a brand of tablet. And since hours is a scale type data, this is a scale type data, tablet is a nominal data, so I have to assign value labels. Okay, 1 for tablet A, 2 for tablet B, and so on. Okay, so that is why here we have, actually if when I click here, it shows the value labels, right? Labels or the values, right? So these are the values and these are the labels. Okay, so this is my data in SPSS. Okay, so this is how we can create the data file for your one-way ANOVA, right? Now, before applying any statistical method, in earlier session also I told you, before applying any statistical method, it is good practice to explore the data. Okay, so exploratory data analysis is very, very important because it gives you some insight about the nature of the data, about the different aspects of the data. Okay, so the easiest way is to explore the data and compare the means, right? So let me show you here. So go to analyze and in compare means, right? So remember, go to analyze, compare means, and here means. If you click on means, it shows the dependent list and independent list, right? So dependent variable is always a continuous variable for one-way ANOVA, right? And brands, that is the independent list, right? Click on the options. You can select here different statistics from this, right? Say for example, I can select this number of cases, right? You can change the order, number of cases, mean, standard deviation. You can use the maximum, minimum, or standard error of the means, standard error of the means. You can select the minimum value, you can select the maximum value. Okay, and then just click continue. Okay, and click OK. So it gives you the output like this. The first table is always a case processing summary, right? So if there are any missing cases, so it will highlight the missing cases, right? Otherwise, here I have 25 observations, so it shows 25, so 100% data is included here. Okay, then the next table is about the summary table, right? That is a report table. Let me show you in the presentation itself. Okay, so look at this. This is my first table. Okay, so what it gives you, it shows the brand, the number of cases in each brand, number of observations, then mean for each, mean number of hours of relief for each brand, standard deviation, and standard error. Okay, so this is how we can explore. So from this data, it is clear that if you look at the output, it is clear that for tablet D, the number of hours of relief, average number of hours of relief, that is 2.98. Okay, so that is smaller, and for tablet B it is larger, 7.9 hours it takes to get the relief. Okay, so this is how we can explore the data to get idea about the center of the data, about the spread of the data, right, about the minimum and maximum of the data. Okay, so this is the summary output. Okay, the next one is graphically, explore graphically, right? Now to explore graphically, again, you know now how to analyze the data graphically. So you can go to graph, right, legacy and box plot. Now why box plot? Because I have one dependent variable that is continuous and another categorical variable that is a nominal. Okay, so take a select a simple, define, right, select variable as hours of relief and brand of tablet as a category axis. Okay, as a category axis, right? Now other things is not required, so just click OK and you will get the graph that is a box plot. Okay, so this is the box plot, right? So let me show you in the presentation. Look at this. This is the box plot, right? So along x-axis, it takes different brands of tablet. Along y-axis, hours of relief, right? And we have a box plot. If you look at the data, so in the tablet E, there are two outliers. 23rd number observation and 24th number observation is the outlier. Okay, so this shows that there are two outliers, right? So still I am using one-way ANOVA. So let me show you. Okay, now how to apply one-way ANOVA. Okay, so go to the data file, then analyze, compare means, right? So in compare means there are five different options. First, already we have seen means, then one sample t-test, independent, paired, that you learn, right? One-way ANOVA. Because I have only one factor for the classification of the data, so it is a one-way ANOVA, right? So dependent variable, that is hours of relief, independent, that is factor, that is brand of tablet. Okay, then after this you can go for additional options, right? So after all this you can go for additional options, right? So suppose the null hypothesis is rejected, right? If the null hypothesis is rejected, I want the post hoc analysis, right? So you can carry out the post hoc analysis in advance. Otherwise what happens? So if you do not select post hoc right now and apply the one-way ANOVA, and then you realize that the null hypothesis is rejected, then again you have to go for the post hoc analysis. Again you have to repeat the entire process, right? So instead of that, directly you can select here post hoc analysis. So you can select either LSD or Tucky. So look at this. These are the different methods of post hoc analysis: LSD, Tucky, Bonferroni, right? Then this Donut test is there, that is for control groups only. Okay, so let us select the LSD and Tucky only. Okay, so continue and then go for the options, right? In options, what we have to do? So remember the assumptions. What are the assumptions? Equal variances. So here also we have to check the equal variances, right? So first one is the descriptive statistics, right? Because we want the descriptive summary of the data also, right? Then homogeneity of the variances, whether the variances are equal across the different tablets, that we want to check. Okay, then you can go for a mean plot also, right? So then continue and then simply click OK. So it will give you the output like this. Okay, so this is the first one, that is a descriptive summary. Okay, for all the 5 brands of tablet, and for the dependent variable as hours of relief. Here it shows the variable hours of relief, right? Number of cases, number of observations, their means, their standard deviation, their standard errors, along with the 95% confidence interval for the mean of each brand of tablet, right? For the mean hours of relief for each brand of tablet, right? And minimum and maximum. Okay. So this is the output. Okay. So this is the output for that. Okay. At the same time, actually, we want to compare whether the variances in the hours of relief due to the 5 different brands are equal or not, right? Because one way ANOVA is used when we have equal variances. Okay, when we have equal variances, then only we can go for this. Okay, so variances in the hours of reliefs are equal against they are not equal. This hypothesis I want to test, right? Now for the equality of variances, we can use the Leibniz test. Okay, this is the Leibniz test. Okay, and this is the value of the test statistics, and this is the p-value of the test, 0.706. Okay, 706.706, right? Now look at this. Since the p-value is not less than 5%, it is not less than 5%, we fail to reject the null hypothesis, right? We fail to reject the null hypothesis. That means H0 is not rejected. That means variances are equal across the different brands of tablet. Okay, so equality of variances is clear. Okay, now our main hypothesis, that is there is no significant difference between the mean number of hours of relief due to different brands of tablet. You can write this in terms of parameter also, mu1 equal to mu2 equal to and so on equal to mu5. That means mean for all the brands of tablet is same against at least one pair differs significantly than the other. Okay, so this is the hypothesis which I want to test, right? Now if you look at the output, right? So this is the descriptive, this is the homogeneity of the variances, and the next part, that is analysis of variance. Okay, so as I showed you earlier, source of variation, that is a between groups, within groups, and total variation, right? So in the entire data, the total amount of variation is 137.954, and that is split into two component variation, that is a variation due to different brands of tablet, that is 78.42, and variation due to error, random variation, that is 59.53. Okay, and you look at this, how many groups we have? We have 5 groups, 5 brands of tablet. So k minus 1 degrees of freedom, that is 4. Total 25 observations we have. So 25 minus 1, that is 24 degrees of freedom, right? And then for error, we can calculate 24 minus 4, so it is 22, right? And these are the mean sum of squares, right? That is sum of square divided by the degrees of freedom. And finally, the F ratio, that is the mean sum of square between the groups, that is 19.60, divided by within the groups, that is 2.97. And this F ratio comes out to be 6.58, right? Since we are doing the one-way ANOVA with the help of software, so directly we get the p-values, so we can use the p-value approach, right? We can use the p-value approach. Okay. Okay, so if you look at the p-value, it is 0.001. Okay, the p-value of the test is 0.001, which is less than 5%. Okay, p-value is less than 5%. Okay, so What is the decision? So since it is less than 5%, we reject the null hypothesis at 5% level of significance. You can compare at 1% also. Okay, you can compare at 1% also, but generally we can use 5% or 1%, right? So when we say reject the null hypothesis, it means that if you look at the data, reject this H naught, this is rejected. It means H naught is accepted. At least one pair differs significantly, right? So at least one pair differ significantly. Okay, H naught is HA is accepted. Okay, great. HA is accepted, right? So at least one pair of tablet differs significantly with respect to mean hours of relief, right? Now again, I repeat, when the null hypothesis is rejected, then only the post hoc analysis is useful. If it is not rejected, then post hoc analysis is not of any use. Okay, now since we reject the null hypothesis, right? So pairwise comparison is applicable, right? So we can use the Tucky HSD or LSD, right? So let us see the output, right? In the output, look at this. The first part is, since we have selected both, okay, HSD as well as LSD, you can select any one, right? And there is a minor difference between the formulas of Tucky method and Fisher's method. Okay, so what it gives you, actually try to understand, because this is very, very important for the interpretation point of view, from the interpretation point of view, right? So look at this, I and J, I brand of tablet, J brand of tablet. Okay, so all possible pairs, right? All possible pairs. Actually, here in the output, it shows all possible pairs, right? So look at this, tablet A and tablet B. Okay, at the same time, if you go for tablet B, so tablet B and tablet A, so they are exactly same. Only the difference is here I is taken as A and J is taken as B. So the main difference is I minus J. So look at this, minus 2.46. Here it is 2.46, because the difference is not I minus J, it is reverse. Okay, because this is I and this is J. Okay, just a minute. Okay, so this is the main difference for all possible pairs. Then standard error. Standard error remains same because in each category we have equal number of observations, so it remains same. The next column is the significant value, that is the p value, which is of great interest for us, right? So look at this. If you check in the first pairwise comparison, all the p values are greater than 5%. Okay, in the second row, tablet B and C, it is 0.026, and tablet B and tablet D, it is 0.002. Okay, so this column is most important for us. Okay, so let me show you the same thing in this presentation. Okay, so look at this. This is the output, same output. Okay, so tablet B and tablet C and D, right? Tablet C and tablet D. Okay, for these two, the p value is less than 5%, right? Is less than 5%. Exactly same way, if you go for tablet D and tablet E, right? So this is 0.012. Okay, now see, in the third row also, tablet C and tablet B, but that is already noted in the second row. So whether to consider this or this, it is exactly same. Okay, so these three pairs, okay, which three pairs? B with C, this is one pair, B with D, another pair, and tablet D with tablet E. So this pair differs significantly with respect to mean number of hours of relief. all other pair do not differ significantly. Okay, so look at this. Okay, so tablet B and C, tablet B and D, tablet D and E. For all this, the p-value is less than 5%. Again, I show you, right? Look at this. For this and this, so they are less than 5%. Okay, so we can conclude that mean hours of relief differ significantly due to tablet B and C, okay, due to tablet B and D, okay, due to tablet D and E. For other pair, the p-values are not less than 5%, so there is no significant difference between the other pairs. Okay, so this is how pairwise comparison is used. You can also compare from least significant difference also. Okay, you can also compare the least significant difference from LSD, that is Fisher's test also. Okay, so this is how. Another important output this gives you, that is very, very important, this output, homogeneous subset. This is only available when you selected Tucky HSD, right? So look at this. There are three subsets. Okay, there are three subsets and brands of tablets. So the order are according to the subsets. Okay, so this is very important part. Okay, so look at this. Tablet D, C, and A, they belongs to one group, right? It means that tablet A, C, and D do not differ significantly because these are the homogeneous subgroups, homogeneous subsets. Okay, at the same time, the second subset, that is C, A, and E. So C, A, and E do not differ significantly, right? Similarly, this A, E, and B, they belongs to the third subgroup, so they do not differ significantly. Okay, they do not differ significantly. Now, which differ significantly? So if you cross here, right, say for example, this is the D, right, and take any one from this, right, any one from this, so that differs significantly. Okay, so you can check B and D, B and E, right, so they differ significantly. So that means that these subgroups, these subsets are homogeneous subsets. So D, and if you take another one, then there is a significant difference. So these homogeneous subsets are very, very useful in the analysis, in reporting also. Okay, so this is available only for the Tucky's HSD method. Okay, so and this is how you can interpret that this belongs to the first subset, so they are homogeneous. These three belongs to the second subset, so these are homogeneous, and this belongs to the third subset, so these are homogeneous. Okay, so this is how we can apply the one-way ANOVA in SPSS, right? At the same time, since we have selected the mean plot, so it shows the mean plot, right? So these are nothing but the mean values, right? Along y-axis, we have mean of the hours of relief due to tablet A. This is the mean. Due to tablet B, this is the mean. Okay, and so on. So from here also, you can just along with the table, along with this table, you can show this plot also. Along with the table, you can show this plot also. And this is again a simple way to visualize the means of the dependent variable for various independent variable. Okay, so this is how we can go for the one-way ANOVA, right? Now the next part is two-way ANOVA. Okay, so two-way ANOVA is exactly same with one-way ANOVA, only the difference is in earlier we have only one factor for the classification. In two-way ANOVA, we have two categorical variables, right? Two categorical variables, say factor A and factor B. So there are two categorical variables. Okay. So here I have taken the example, that is, so a physical therapist wish to compare three methods of teaching patient to use a certain prosthetic device, right? How to use a prosthetic device, right? There are three different methods that researcher want to compare, right? So he felt that the rate of learning would be different for the patients of different ages, right? So one is three different methods are there, right? And the researcher felt that the age factor may also play important role. So he divided the patients into different age groups, right? And collected the data, right, about the rate of learning, right? So this is the data. So time in number of days required to learn use of this prosthetic device, right? According to A method, according to B method, according to C method, and for under 20 age group patient, 20 to 29, 30 to 39, and so on. So if you look at the table, there are three variables. One is a different teaching method, another is age group, second variable, and the third variable. These two variables are categorical, and the third variable is time in number of days. So these are the times in number of days required to learn the use of prosthetic device. Okay, so in this case, we have the dependent variable, that is time required to learn, and the independent variables are methods as well as the age groups. Okay, so this is okay about the two-way ANOVA. And the model, now I am skipping all this mathematical because it is exactly same. I will share the presentation. Okay, instead of alpha I, now I have beta j also, because I have another factor, another categorical variable, right, with B levels. So alpha I, so there are A levels of factor A, small a levels, there are B levels of factor B, right? And the observed value Iij is due to the general effect, or it may be due to the different teaching methods, or it may be due to different age groups, and rest is due to the random component, that is error component. Okay, now assumptions are exactly same to that of the one-way ANOVA, right? Now in two-way ANOVA, we have to test two different hypotheses. One is for factor A, that means there is no effect of levels of factor A on the dependent variable against at least one pair differ. Second is for factor B, again there is no effect of levels of factor B on dependent variable against at least one pair differ significantly. Okay, now try to understand this. According to the definition of ANOVA, total variation is split into two variations due to assignable causes and due to chance causes. Okay, so chance causes, that is a random variation which we cannot control, right? But we can control the assignable because we are applying different teaching methods. So because of that, there is a variation. Because we are dividing the patients in two different age groups. Okay, so due to factor A and due to factor B. So assignable variation is further split into component variation due to A factor and due to B factor, and the rest of the variation is due to chance. So here we have total variation equal to variation due to factor A plus variation due to factor B, and rest is due to the random component. Okay, so this is how we can categorize the total variation. Okay, Now I'm skipping this because main goal is to show you how to perform this in SPSS, because all these formulas are available in all standard books, right? And it is exactly same as one-way ANOVA. So look at this, the source of variation here. The source of variation is factor A, factor B, random, and total, right? So there are four source of variation. Total is divided into three components due to factor A, due to factor B, and due to error. Rest of the logic is exactly same. Okay. Now, since we have to test two different hypotheses, we have two different test statistics, right? For group A, for factor A, we have to use mean sum of square due to A and the error sum of square, right? For factor B, we have to use mean sum of square due to B divided by the mean sum of square due to error. Okay, so it is exactly same because of the time limit. Rest of the part is exactly same. So I am directly coming to again pairwise comparison. If the hypothesis about factor A is rejected, go for post hoc analysis. If otherwise, not required, right? If for factor B it is rejected, then go for post hoc, otherwise not required. Again, this post hoc is as usual. Okay, now how to perform this? So let me show you. Now again, the most important thing is variables, number of variables. So as I told you, in this particular table, there are three variables. One is the time required to learn, that is these numeric values, that is the scale variable, continuous data. Okay, second variable is teaching method, third variable is age, right? So I have to enter the data accordingly, right? So let me open the two-way data. So this is my two-way data. If you look at this, so time required to learn the prosthetic device, right? And teaching methods. So there are three teaching methods, A, B, and C, and age group. If you check the variable view, so look at this. In the variable view, I have 3 levels in the teaching methods and 5 levels in the age groups. Okay, so this is again in the teaching method. I have the data type is nominal. Okay, but age group, so that is a ordinal data because age. So here order is important. So that is why I have selected here it is an ordinal, and the time required, that is a scale. So these things are very, very important while applying the ANOVA. Okay, while applying two-way ANOVA. Okay, so I'm skipping few parts. Okay, so about the hypothesis, right? So this is the hypothesis for the factor A, this is for factor B, right? Again, you can go for the first basic exploratory analysis, that is compare means. Okay, in compare means, right, select the time required and teaching method and age in the independent list. In the option, you can select standard error of mean. Okay, a mean number of cases. You can select minimum and maximum as well, right? And then continue and click OK. So you will get the output, right? So look at this. The first one is a case processing summary. Second part is for time required and teaching method, right? So it is shown here, time required by teaching method. Okay, so look at this. Their means, number of cases, standard deviation, standard errors, and all. Same for age groups. Okay, so this is the summary for the exploratory summary for the data, two-way data. Okay, again you can go for the box plot. Again it is exactly same, so I'm not repeating it because I want to show you the next part. Okay, so go to the graph, legacy, and all this, follow all these steps, right? And you will get a box plot like this. Now the thing is here, this box plot is okay. Okay, yes, Dr. K. Shiva. What is your question?
Okay, Shiva, you can ask your question. You have made co-host.
Yeah, you
By
are.
mistake, you would have lifted his hands. No
Hello.
question. By mistake, sir.
Sorry,
continue,
sorry.
sir.
Okay, no problem. Okay, sir. Okay. Now look at this. The box plot is slightly confusing here. The reason is, let me show you the reason. So if you look at the data, right? If you look at the data for the B part, that means for the B teaching method, almost in the 4 age group, the time required is exactly same, 9, 9, 9, 9, and for 1 it is 12. Okay, so because of this, the box plot looks like this. Okay, so this is the outlier because almost all 4 observations are same. So it shows at the 9. This is the value 9. Okay, so that is why it shows like this. Okay, so similarly for the another one, that is age group, we have the box plot. Okay, now how to apply two-way ANOVA? Okay, now see, if you go to the analyze tab and compare means, there is no two-way ANOVA. Okay, so it is available in the general linear model, right? So madam, I am taking 5 minutes more because I have to finish this, and it is very important, two-way ANOVA.
Okay, sir.
Okay.
Okay. So see, directly in analyze compare means no two-way ANOVA is there. Okay. So that is why I have to show this particularly. Okay. So in the general linear model, go to univariate. Okay. And there are certain options which are very, very important for the selection. Okay. So again, I repeat, analyze, general linear model, and go to univariate, right? So dependent variable, it is a scale variable, that is time, right? And then teaching method and age groups, one is nominal, another is ordinal, and it is considered as a fixed factor, right? So if you are aware, so there are some ANOVA techniques in which the independent variables behave randomly also, right? So in that case, that means there are certain assumptions about the independent factor variables, right? About the distribution. So in that case, you can select that in a random factor, right? So right now I am focusing only on fixed effect model. Okay, so this is how you can select. Okay, now after this, the next step is very important, to select the model, right? Because same techniques, same steps are also applicable for the factorial experiment and two-way ANOVA. That is why it is very important to show you. Okay, so go to model, right? So look at this. It shows by default full factorial. In full factorial, we might be interested in comparing the main effect of teaching methods and main effect of age groups, as well as the interaction effect of age group and teaching method also, right? But right now my focus is only two-way ANOVA without interaction. So just click on the customize, okay, and then select the main effects. Okay, select the main effects, teaching and age. If you want interaction effect, you can select the interaction effect also. Let me show you. So if you select the interaction, so it will be like this, right? It will be like this, age into interaction, right? But it is not applicable for this particular model. Okay, so and then simply continue, right? So this is how you can customize for two-way ANOVA. Okay, so this is one thing. Another thing is the post hoc analysis. Since I have two independent variable, one is a teaching method and another is a age group, so I have to compare, I have to use post hoc analysis for both separately. Okay, so you can go for the post hoc analysis, right? Select teaching method as well as age, right? And you can select the Tucky's method and continue. Okay, so this is how we can select the option, right? Another is, this is already I showed you, continue, right? Continue, and then just simply click OK, right? Simply click OK, and it will give you the output like this. This is the univariate summary. Okay, so between subject, teaching methods 1 to 3, number of cases, age group, these 5 age groups, number of cases, right? Number of observations, right? So this is the output. Okay, so let me show you here. Okay, so look at this. This is the output of the analysis, two-way ANOVA, right? So remember, out of all this is not important for us. Okay, it is for the overall model, right? Whether the overall ANOVA model is appropriate or not. Okay, so for us, the important part is teaching method, this one. Okay, so let me show you this one, this row, and this row. Okay, so actually there are different methods of calculating the sum of squares. Okay, so that is why it gives me here the type 3 sum of squares. Okay, type 3 sum of square. There are different methods. Okay, by default it is type 3, right? So this model row is not important for this, right? And this total sum of square, so just add all these 3 sum of squares, so it gives you the value total sum of square. So right now it is based on the model sum of square. Okay, so the degrees of freedom, so look at this. There are 3 teaching methods, so 1 less degrees of freedom, that is 2. There are 5 age groups, so 1 less, that is 4. And we have in all 15 observations. So accordingly, the degrees of freedom, and these are the mean sum of square, and these are the p values. Okay, so both the p values are less than 5%. So we reject the hypothesis about the teaching methods, right? That means there is a significant difference between the time required to learn using different teaching methods. That means methods differ significantly, right? This is according to the teaching method. Then according to age group, again, the value is less than 5%. So there is a significant difference between the mean time required to learn for different age groups. So age group wise also there is a significant difference. Okay, then along with this, it shows some additional output also, right? So along with that, it shows the additional output. Okay, so these are the additional output. Okay, okay, so these are the additional output. These are the marginal means. Okay, for the dependent variables, time required and the teaching method, then time required and age group. These are the marginal means. It is exactly same as one-way ANOVA. Okay, and then the multiple comparison. Look at this. Method A is compared with B and C, right? And if you compare this method A and C, so the value, significant value is less than 5%. Similarly, for B and C also it is less than 5%. Okay, so here we can say that this two pair A and C differ significantly, B and C differ significantly. Okay, so this is how we can compare the pairwise, right? So these two pair differ significantly. Okay, so similarly, the homogeneous subset. So look at this. Method A, this is the mean. Method B, this is the mean. So these two groups are homogeneous. That means A and B, there is no significant difference. But if you choose one from this group, A, and one from the second group, so A and C differ significantly, B and C differ significantly, right? Exactly same way you can compare the age group wise also, right? So instead of comparing this, let me compare the last one, right? So look at this, 50 and above age group patients, right? So for all possible pairs under 20 and 50 and above, So the p-value is 0.01. So see, all these values are exactly same, which are listed below. Okay, so first one is under 20 and 50 and above, there is a difference. 20 to 29 and 50 and above, there is a difference. 30 to 39 and 50 and above, there is a difference because all are less than 5%. Okay, so they all are less than 5%. Okay, and the last one, which is most important, homogeneous subset. So look at this. Under 20 to 40 to 49. So all these 4 age groups patients have homogeneity, right? That means their learning approach is same. Time required to learn is almost equal, approximately, right? So there is no difference. But if you take one from these subgroups, that is, say, for example, A, under 20 and 50 and above, so they belongs to different subsets. So there is a significant difference. 20 to 29 and 50 and above, they belongs to different subset. So there is a significant difference. Okay, so this is how we can perform two-way ANOVA in SPSS. Right now, if you have any questions, I am ready to answer your question. If you have any questions, queries, please feel free to ask the questions. Hello, Subhashini Raman. You can type the question or you can ask the question.
Good evening, sir.
Good evening, good evening.
Sir, can you give an example for the independent variable of random factor in univariate, what you said to put it, no?
Okay, random factor. Okay, so random factor means many times what happens. So we have the factor variable, say for example, age group, right? So in that scenario, suppose your variable, your data behaves randomly. That means it will affected by certain distribution. Say for example, in our usual way, in your usual model, so we have these EIJs. 1 minute, let me show you that model. Okay, so look at this model. So Yij equal to mu plus alpha I plus Eij, right? So here these errors are normally distributed. That is the assumption. That means errors are having some normal distribution with mean 0 and with some variance, right? Now instead of that, means this is about the errors, right? Now alpha I, that means they are fixed values, right? But if alpha i's are not fixed, but it follows some probability distribution also, right? So this factor variable is also having some distribution. Like here it is mentioned that errors are normally distributed, and suppose alpha i's are having some normal distribution or following some exponential distribution, then in that case we can go for that random effect model.
So that means we have to put that factor in the random factor instead of.
Yeah. So before applying this ANOVA in SPSS, we have to check whether the data is coming from a particular random distribution. That means whether that factor is coming from a random distribution, whether it is affected by randomness. Okay. Okay. So then only we can go for the random. In that case, you can use a random effect model, right? So there are 3 types of model. One is a fixed effect. If all the independent variables are fixed, then we can use a fixed effect model. If all the independent variables are randomly affected, then we can use a random effect model. Many times, say for example, in two-way ANOVA, right? Let us take the two-way ANOVA example. So in two-way ANOVA, we have, this is the model. Okay, so 1 minute. Okay, this is the model, right? So here, if alpha I is fixed, suppose, and beta j is having some distribution, random distribution. Then we have one effect is fixed, another effect is random. So that is known as a mixed effect model. So accordingly, you have to select in SPSS that whether it is fixed or random, or whether all are fixed or all are random. I hope.
Okay, sir. Sir, one more query.
Okay.
We used univariate for the two-way ANOVA.
Yeah.
Multivariate, can it be used for the factorial?
Yes. You can also, because
More
see,
than
yeah, because just like Anova, we have Manova. Okay, that is a multivariate analysis of variance. Okay, so multivariate analysis of variance means the dependent variable Yij is not a single variable, but we have multiple variables. Okay, we have multiple variables, dependent variables. Okay, so in that case, you can go for Manova also, and even in this analyze and generalize. So look at this. So here we have a multivariate technique. Okay, so here you can select multiple variables also. Is it clear?
yes, sir. Thank you, sir.
Okay,
Sir,
thank
there
you.
is a question in the chat box.
Okay, let me check.
Two questions are there.
Okay. Okay, in post hoc analysis, we take significance level as 0.05. Okay, so it has nothing to do with number of categories. Okay, it has nothing to do with number of categories. So basically in hypothesis testing, we have the predefined value of the level of significance alpha. Either it may be 5% or it may be 1%. If you want more accuracy, you can go for 1%. So when we say alpha equal to 5%, it means there are 5% chances of making type 1 error. When we say 1%, so there are 1% chances of making type 1 error, right? So it has nothing to do with the number of factors. Okay. Another one is what parameters to be considered to select particular post hoc test. I have seen DMART and done. Okay, so actually, as I told you, no need to take any parameter. The only thing is, if you want to compare, suppose I have a treatment, factor is a treatment, say for example, fertilizer. Okay, so if I am comparing 4 different fertilizers, so I have fertilizer A, B, C, and D. So all are the treatments. Okay, there is no control group. So I can go for least significant difference. I can go for Tucky HSD, right? You cannot go for Donut test. Okay, so Donut test is used only when we have a control group. Control group means a placebo group. Say for example, I want to compare 3 fertilizers. Okay, I want to compare 3 fertilizers along with one that is a control, that means placebo. So in some plots of a farm field, I apply A fertilizer. In some plot I use B fertilizer, in some plot I use C fertilizer, and in some plot no fertilizer. When we say no fertilizer, so that is known as a control group or placebo group. So when you want to compare a control group with a treatment, then only we can go for the Donut test. I hope.
Or if you are having the p-value of less than p-value is less than 0.01, you are saying another condition like if our p-value is 0.05, which will be more effective. We can say the significant value. We can say
more effective in the sense based
means
on the
p-value, based on the p-value.
Based on the p.
If it is less than 0.05, or we can say 0.01, which one is the best idea?
Okay, obviously 0.01 is more significant, na?
Yes, that's why, sir. That's why
okay. That is obviously because your chances of making an error is very less as compared to 5%.
Yeah.
Okay, exactly.
Thank you, sir. Myself, Snehasamani Sonja from UP, sir.
Thank you, madam.
Thank you, sir. Thank you.
Thank you. So, okay, can we denote degrees of freedom in lower case letters too. Like and yeah, you can denote it. See, look at this. In the output, it is I have just highlighted it in capital letters so that we focus on that. That DF, that is the degrees of freedom, is an abbreviation. But we can see in the output itself, SPSS shows in small letter DF. Look at this. It is a small letter. Okay, so it doesn't make any difference.
Because we
Okay.
learned it as a small case letter.
Yeah, you can use small case letter also, and you can use capital case letter also, because in some textbooks it is denoted by capital DF, just to highlight that it is an abbreviation for degrees of freedom.
But
Okay.
you have denoted as capital N and
No.
A.
That is why I am saying, because I have denoted it in capital letters just to highlight that it is an important aspect.
Okay.
Okay,
Thank you, sir.
it is some important term. That is why I have used the capital letters, right? It
That
is
means the same.
The meaning is exactly same. It is not. It is an abbreviation for the degrees of freedom.
Okay. Thank you, sir.
Thank you. Any other question? I hope you learn something from today's session, and
Yes,
it is
sir.
very important in almost all analysis of variances techniques. These two techniques are very common, and apart from this, we can go for the higher, that is a factorial ANOVA, CRD. I think in one of the session earlier session, someone asked about CRD. Okay, so remember, CRD is exactly same as one-way ANOVA. RBD is exactly same as two-way ANOVA. Only the difference is here we have not, in one-way ANOVA, in two-way ANOVA, we have not used any principles of design of experiment, right? So we have a data categorized with respect to one factor or with respect to two factor. So we go for one-way and two-way ANOVA. But when you have to plan actual experimental study, then you select the plots, you select the objects, you assign the treatments to the objects randomly, right? So there are three principles of design of experiment: replication, randomizations, and local controls. So if any one of these three principles are used, then we have to go for CRD, RBD, and higher designs. Otherwise, for such a data, directly we can go for one-way, two-way ANOVA. And one-way ANOVA analysis, same way you can perform CRD in SPSS. Two-way, it is exactly RBD in SPSS. So thank you very much, madam.
Sir, can
Hello.
we wind the session, sir?
Yeah. I have finished, madam.
Okay, sir. Today, sir has neatly explained the difference between observational study and experimental study. What is ANOVA, one-way ANOVA, pairwise comparison, two-way, and how to use it in SPSS, with a nice example of giving with 5 different brands of tablets and the hours of relief for one-way ANOVA, and for two-way ANOVA, he has given time in number of days and methods and age as two-way, how to do it with nice examples, which was easily received, well received by all the participants. Thank you, sir. If you see in the comment box, it was given informative and excellent session, very useful. Nice comments have been received on your session, sir. Thank you for your valuable time being spent with us, for sharing your expertise. Thank you, sir, on behalf of IQAC. Thanks a lot, sir.
Thank you very much, madam. And
Thank you, sir.
thank participant for such an excellent response. Thank you.
Okay, sir. We'll be again meeting tomorrow, I think. Is it?
Yeah.
Sir? Yes, sir. Thank you, sir.
Thank you, madam.
Thank you, sir. Sarla, thank you, madam.
Thank you, madam. Thank you.
Ma'am,
Yes.
ma'am.
Till we end the session.
Stop பண்ணிருங்க.